So mostly NFL for you?
Yeah, and I've got a couple of clients that I have.
Yeah.
Come do this.
Are you? Good.
If you have any questions in the meantime, please let me know. Obviously, we have coffee. If you would like some, make sure that you just raise your hand, and we're going to do our best to get everybody served. Help yourself to snacks. There is a toilet up front. What we ask is that you don't put any paper into the toilet. So, other than that, you're welcome to use it while we're on
Do you
board.
have your other badge? Do you have your badge?
Oh, looks like we got one more person.
One more person.
Oh,
Okay,
Stefan,
just get on
hurry
in
up.
and get your badge earlier. That way they can go.
Y'all can be jump on.
There we are.
How are you? Very good.
Come on in.
I didn't get his badge.
That's okay. I know
wanted to get you going.
He's good.
Say, there is some space in the back. Morgan, grüß dich. See, then I can also see what's happening. Are you-
We have a new recording setup, so hopefully we won't have any hiccups and we'll be able to move right along.
No put it here for the time. 20 minutes. All right, good morning. Welcome everybody. My name is Dirk Sikora. I'm a business development manager within Lawol, specifically for media infrastructure. So I would say the IP-based solutions that we provide. Today I'm going to talk a little bit about the global events and how IP workflows were being used on these global events. So I believe we all know that last summer was a pretty busy summer. We had two large sport events, one in France, one in Germany. Given the limited time, 20 minutes, I'm going to focus on the event in Germany where we were watching the football tournament. However, the technology used on both events were quite similar. So just to dive into a bit of a quick high-level overview, I'm going to fly pretty high-level helicopter overview over what we were actually doing. First of all, in Germany we had 10 venues. With a central IBC, several production teams were being used on all the different hubs to produce the content. All the video content was produced locally in the stadiums in 1080p HDR, and all the audio content was produced in three formats: immersive 5.1.4, surround 5.1, stereo, and last but not least, in every stadium there were up to 150 commentary positions being used. So very quickly, there is a bit of delay on my clicker. Just a high-level overview. Every match was being recorded with a minimum of 33 cameras. From the quarterfinal moving forward, we had 46 cameras and a combination of different types of cameras, of course. On the audio side of things, we were using 56 microphones to produce the international mix. And this was a combination of ORTF microphones, field of play microphones, wireless microphones, camera mics, and so on. Now, from every venue, there was actually a full redundant network connection to the International Broadcast Center in Leipzig. This was handled with full redundant. There was 400 gig of bandwidth available, a red and a blue network, each providing up to 200 gig of network connectivity. This network was used for all the transport video signals, multilateral feeds, unilateral feeds. I have to point out there was a bit of a difference between the tournament in Germany, where all the video signals were transmitted uncompressed, where we provided in France a different type of solutions, where the video signal transport was done based on JPEG-XS. But again, I'm going to focus on the tournament in Germany. So all the signals were then being transported to the International Broadcast Center. For the people that don't really know what it is, this is like the temporary hub where all of the broadcasters are being located, all of the right holders are being located. There's a lot of activity actually happening there in that broadcast center. Within the broadcast center, we have the master control room. So the master control room is the space or the place where all of the signals are being received, are being monitored, and are being distributed. So within that master control room, all of the live stadium feeds, the camera feeds, individual camera feeds, the different program feeds like the team player A, team player B feeds are being received, all of the unilateral feeds are being received. And what is really important to understand is that there is a multi-feed approach. And what do I mean with that? Within that within the MCR, people are using 1080p HDR content, but also monitoring 1080p SDR content and 1080i. So that's important to understand. I'll come back on that. Next to the master control room, there is like the quality control room. This is not really like the technical center, it's more like productional. So these people are in touch with the production teams on site and they are actually monitoring, let's say, the quality and the consistency of the international feed being created. Then the next room is like the audio control room. So this year there were two immersive audio control rooms being built in the IBC, and also in these rooms every game was being mixed full in immersive audio. So locally on the stadium side there was the 5.1 and the stereo mix. However, in the IBC there was the immersive audio mix. So here in this room they were actually doing the live mix from every game. Last but not least, there is also the transmission and the distribution. So from the IBC, all of the signals that are being received from the venues are then being redistributed to the whole world. And this is done based on three key pillars: network, file-based content, and satellite feeds. So you can actually see here, and later on you can review the slides, you can see how this was done in detail. Now, how was IP the key to build a successful project? I'm technical details. So first of all, we delivered a whole solution where we provided connectivity, where we provided processing, where we provided a management and control system, and of course the human interfaces, touchscreens to operate the whole system, fader panels to do an audio mix, and so on and so on. If we look at the solution here, which was fully based on IP, we start with the physical I/O. Physical I/O actually, where we used a full IP-based system to connect all of the signals from the venues back to the IBC. So, as already explained, we had a full redundant 200 gig pipe. Over those pipes, we transmitted all of the audio and video signals and the metadata signals based on 702110. So we had 10 venues, one large network. It was fully NMOS controlled, based on 702110. Now, to dive a bit more into technical details, you actually see here like a small picture from the kits in the venues. So this kit was actually built out of a full redundant Arista network, being connected to the dual redundant 200 gig pipes. There was, apart from the Arista network, there was a full redundant Cisco network for the management and control. So there was even, the design was fully based in a full redundant part, both on streaming and on control. Then in the flight cases, locally in the venue, we had a full redundant Meinberg PTP master clock system. So this means that the network could provide P2P transport, that was no problem, but if there would ever be an issue with clock distribution, then it was even decided to have a full redundant Meinberg P2P master clock on site, connected via GPS or synchronized via GPS. And of course, we were then from Lawo providing all of the .edge gateways, which is like a very high density solution. In a single frame, we could actually connect up to 192 SDI connections. The whole system was even battery powered, so if the whole stadium, if the whole venue would go down, the system would still continue to work. Now, apart from that, within the IBC, we also provided all of the SDI gateway functionality, fully based on IP again. So for the users in the IBC, they didn't really have like a difference in operational mode between the signals locally handled in IBC or the signals coming from the venue. For them, it was actually one large, I would say, video and audio router, so they could just route any signal from anywhere to anywhere. So for them, it was like a router experience where they had like a combination of the distributed signals and the local signals in the IBC. Just keeping an eye on the time. We're 8 minutes in the presentation. So the processing this year, and that I would say was for the very first time done on a large scale event, was fully based on IP-based workflows, however, not using physical devices. This means we were using a server-based platform to provide both audio and video processing. This server-based platform was actually providing a solution where we decoupled the software from the hardware. What does this mean? That there was no specific device to provide software function 1, another device to provide software function 2, another device to provide software function 3. So we actually had one generic platform where we did both audio and video processing within the same server-based platform. Just important to note is that the technology that we deployed there is using fully cloud-based technology. So this means that you can deploy this technology locally on-prem, but you can also run it, for example, somewhere in AWS or in any other cloud-based facility provider. Now, let's take a quick look a bit more in detail what we actually did. You actually see here a picture from the technical center in the IBC, where we installed a central cluster of servers. You can see we had a total of 20 servers providing this audio and video processing, every server connected to the same streaming network, the Arista network, and we had a 100 gig connection, full main and redundant, going to every server. So all of this technology was using just standard Dell servers, but very frank, you can run it again on any type of server. What we actually do? Every transmission path as a start was processed within these servers. We had 274 outgoing transmission paths within the IBC. Now, why did we need this processing? First of all the feeds coming from the stadium were produced in 1080p HDR, because that was the standard set by the organization to do the video recording. However, we all know that a lot of right holders are using 1080p SDR or even 1080i. A lot of right holders are not transmitting in 1080p HDR. So this means that every feed coming from a venue was going in this stack of servers and was being then converted from HDR to SDR. So we had like HDR SDR processing, color correction, and on top of that we also did interlacing to provide an output based on 1080i. So we had within this stack of servers both HDR SDR processing, interlacing. We did up conversion to UHD as well. Some of the right holders were expecting UHD content. However, the production was in 1080p. And then for the return feeds, we did a couple of down conversions as well. Apart from the UDX, we also provided stream transcoding. To be very transparent, this was not done in Germany. This was done in France. Because I explained in the beginning that in France, the network connectivity to the venues was done, or the signal transport was based on JPEG XS. So in France, we provided stream transcoding, also based on server-based technology, where we were receiving the JPEG XS streams coming from the stadium and in the IBC converting them to 2110. The other way around as well, we received 2110 streams uncompressed in the IBC and we were redistributing them to the venues based in JPEG XS. So, next one was the multi-viewer. Once all of these signals were being transmitted into the MCR, into the IBC, they had to be monitored. And all of the multi-viewers were also based on a full IP-based Laravel solution, providing the monitoring for all the incoming and all the outgoing signals. Next, we had the immersive audio mixing rooms. I already explained in the beginning that locally in the IBC there were 2 immersive audio mix rooms, which were also receiving over the same redundant network all of the audio signals from the venues. So every single microphone was being transmitted to the IBC over the same network using 2110, or you could say AES67. And every single microphone was then being mixed locally here in the IBC. The mixing console is just like a remote control panel. I would say it's like your mouse and keyboard. You actually remote control a DSP, which again was running in your network as an application running there. Next one was the commentary. I explained in the beginning of the story that within every venue there was a maximum of 150 commentary feeds. Now, over all the venues, spread over all the venues, we actually installed 500 commentary positions, and they were then, depending on the game, moved from one stadium to another one. What is important to know is that these commentary positions were locally controlled in the CCR, which is the commentary control room, but the central processing was done in the IBC. So this means that every audio signal from the commentary positions, again over the same network, was being transported to the IBC. And if we look at the next slide, you can see that all of this audio processing in the IBC was again being pushed into this stack of servers, where we had 240 audio processing channels doing all of the detailed audio processing and even the delay to resynchronize with the video within the same platform. So think that on this whole server stack, we did all the video processing, but also all the audio processing combined within the same server-based platform. So Last but not least, such a system needs a proper system management. A proper system management because users will not dive into IP, deep IT technology. They need like a proper interface to control of this. And we actually did this with our home and VSM-based platform. We actually had a dedicated team on site making sure that all the users had a right control panel with all the buttons and all the requirements that they needed. So, what is the summary? I would say, for me, the takeaway from last summer was that for the very first time, we deployed a full IP-based solution, but not with dedicated hardware, but actually based on a server-based platform. So we see actually a transformation going from dedicated hardware into a server-based platform. I would say, therefore, you get an agnostic platform, like an infrastructure agnostic platform, where multiple functionalities can be combined within the same platform again. You get a full flexibility and agility. And I want to point out very quickly about the flexibility. This whole server stack was originally planned for the video processing, and it was only when we were on site that the customer came to us and said, well, we actually need to have a possibility to delay all of the commentary audio feeds. And there it was decided actually on-premise to also spin up all the audio processing. And this was possible because we actually provided a solution which could do any of that processing. Again, what is important as well is the multiple formats. Think about the JPEG XS, the 2110, but you could also combine it with NDI, SRT, even Dante. All of these formats running within the same platform. I would say, therefore, we reduce the need for proprietary hardware. And the final bullet point is, where I see it going, where we as a company see it going, is that we are not going to use a dedicated server stack only for one vendor, but that we're going to combine solutions from multiple vendors within the same server platform. Yeah, that is actually, I would say, today, this is still like every vendor is using its own server stack. How we see moving it forward is that you as a customer will combine it within the same server stack, so that you really have a server-based platform where you can have solutions from multi-vendor approaches running in the same platform. That was it from my side. 18 minutes, so I would say open for questions.
Thank you. Thank you very much.
We have a mic for questions.
Thanks a lot.
Hello.
Yeah, it's working, but it's for the
Okay.
recording.
My question is, do you use the one single PTP Grandmaster for all system?
So there was a main and a redundant PTP system within the IBC. Then the PTP was distributed to the venues. However, in every venue,
Yeah.
there was also a full redundant PTP system installed.
But generally it's using the central PTP
No,
signal.
the priority was set that every venue was higher in priority compared to the PTP coming from the IBC.
Okay. And the second question, do you use any encapsulation, transport encapsulation between Stadium and IBC, or just clear 2110?
Clear 2110, yeah. And in France,
France
also
is, yeah.
2110-22 or being JPEG XS, but there was no transport stream encapsulation if that was the question.
Thank you.
What was the main reason to use JPEG XS in France but not in Germany? Was it total bandwidth or something
Bandwidth.
else? Bandwidth.
So Orange was providing a network in France, 10 gig of bandwidth, where in Germany we had virtually unlimited bandwidth, being used up to 400 gig, 2 times 200.
You mentioned in the beginning that you also transmitted any metadata. What kind of metadata was that?
2110-40. So we actually, at the source site, encapsulated 2110-20 for the video, 31 for the audio, and 40 for the metadata. So all of the user data from the SDI feeds was being transported to the IBC, and they're being used for the recording, the monitoring, showing it on the multi-viewers, and so on. Yeah.
A boring commercial question. In terms of cost for a platform like this, sorry for the voice, What's the cost comparison to a more traditional platform? Obviously, you get more functionality, but
Exactly. So
and also, are you able to predict roughly where the cost fell?
yes. So within this system, the customer decided not to purchase the whole solution, but actually to use it based on a time-limited credit solution. Yeah. So the end customer, they had the system active for 2 months. This means that they only paid for those 2 months. Yeah. And that for the end customer was like also a very important step to select this approach because they did not have to invest in the full system. Now, to be transparent, customers can actually choose for both. And they can choose to purchase the whole thing, or they can choose to use it for a limited time. And this is not only for the global events. I would say this is available for every customer. So for this customer, it was really more interesting to go for that approach because they only paid for the time that they used it.
Ballpark costs?
Yeah, I mean, I would say compared to buying it, you would now spend like 10% of that cost for this event.
I've heard people say a Premier League match in the UK is about 8 million per match.
Well, that's a number that I don't
You're
know,
not familiar,
to be
right.
very transparent.
So
Yeah.
the question compare with SDI solution, full SDI.
Well, I mean, it's for me now at this stage here impossible to make that comparison because as you see, there was like all the remote connectivity, there was like, you know, all of the audio mixing, there was like really like it was the full solution where before you would need like audio cores, you would need like remote stage boxes, you would need like local SDI matrices, and here this actually was completely removed. It was all handled by the same system.
Where is the signal finished in this system? From camera, it's SDI camera?
The cameras were handed over in SDI on this event. Yeah.
Then convert to 2110.
Yes.
And
Yes.
Regarding costs, as you mentioned, does it include hardware, software only, or services as well?
In this example, services as well. Yeah. So on the first slide, you might have noticed I didn't really focus on it because of the time, but there was also a bullet point about the professional service team. So we also included the complete service team. As you might have seen with the control system, we had a dedicated team on site providing this whole solution as well.
You said the network was red and blue Arista.
Yes.
Was that big modular switch or pizza boxes?
A combination of both. Yeah, combination of both. So in the stadiums, they had like the small one rack unit switches. In the IBC, there was a core switch, but not all signals were handled by that core switch.
So it was like a dual star.
Yes.
And the other thing, audio processing offsite incurs delay.
Yes.
I know Bundesliga do it the other way around. They remote control the processing on site.
Yeah.
Why
Now,
did you decide to do it this way?
I mentioned that the stereo in the 5.1 mix was handled locally in the stadium. It was only the 5.14 mix that was handled in the IBC, and therefore this was less of an issue because there it was just synchronized with the video.
Anyone else?
I think my time is up.
Thank you very much. We appreciate that.
Thank you.
Thank you.
I'll swap places with the next one.
And he's right behind you.
All right, so I'll.
We can swap.
And now we welcome Thomas from Skyline.
Thank you.
Who will be taking
Thanks,
over.
I'm just gonna steal my glass
And I
there.
think we need to get you the mic as well.
Oh yes.
Yeah.
There we go.
Welcome everyone. I hope you're good for another presentation for the next 20 minutes. You see also my voice getting down a bit. My name is Thomas Kunkel. I'm working for a company called Skyline Communications. For those who don't know Skyline, you probably have heard about our product, which is data miner, in essence we call it nowadays, it really takes long, a digital transformation platform. It's really something to manage and orchestrate a media organization. But going to the presentation of today, I want to pick up what Dirk has presented, a really nice example of how you can embrace IP technologies and how you can use the flexibility. I guess that's one of the key aspects why people move away from SDI to IP, and it's proven technology. But why is it not always that simple? Because everybody could just go, yeah, let's go IP and that's it. We are all good in media. We know how to run real-time operations. We have done that for 30, 40 years or longer. And now we are in a world where media is becoming IT and more software driven. But at the same time, we know it's not plain vanilla IT, is not something that we can manage through an IT company. It's a pretty specific world. That's interesting. Sorry, I got distracted. Same for you. Little stop. I know. I have my challenge here. Going into the ICT world, we are in a very specific small niche. It's not plain vanilla IT, ICT. And we need to live and embrace those principles. And that's always something I'm talking about, to become much more data-driven, to run, and you've heard about those DevOps principles. You need to run CI/CD platforms to really become a more IT-centric company. In the lack of having the right word, we came up with something, we call it media operations. And that's really to simplify, to be more automated, and to be much more data-driven than before, to manage all this, which was in the past an SDI infrastructure, but now becomes IT. 1, 2, 3. I try again. Okay. What are the requirements to go there? When we look into things you do on a daily basis, we always say everything you do has somehow a life cycle. That starts with running the inventory, planning and reserving your equipment. Then what Dirk was talking about, deploying it, configuring it, running it, controlling it, monitoring it, things we have done also with SDI. You need to decommission equipment again. That's something we have not necessarily done in the past all the time. And then at the very end, there is also a bill and procurement. And that involves multiple teams. And those teams today, when you think about your organization, we work in a pretty analog way. We have digitized technology, but we have not digitized our workflows. You hand over paper from one team to another. Scheduling team has a PDF, gives it to the MCR people. That's not pretty efficient and not digital yet. What else do we see? Need to click faster. It's about the integration with different technologies. We have seen one example just now. Different formats, different vendors, all needs to go together, not necessarily today. When we talk about cloud-based equipment, especially, things can talk to each other. You have still those barriers, but you need a platform that can interface with each technology, each API. The days of SNMP, those are gone. Now we have a lot more different ways to interact and to integrate products. And you need some technology that supports this. So different infrastructure. And next to multiple teams, multiple different infrastructures you come across, you need to digitize everything. That really, again, starts from onboarding inventory. In the past, you just turned the camera on, that was it. Nowadays, onboarding is a critical process. Think about security. We have a lot of security breaches just because people onboard devices not in the way they should do it. Planning, reserving, that needs to be digitized. And that includes infrastructure, that includes people, that includes rooms, that includes your facility, everything you need. You do it in a pretty manual day today, probably. And then something we also didn't have in the past is deployment. Deployment of infrastructure to me means much more that you need to spin things up. You need to run the Lavo system on the stack of the Dell servers. That includes Docker systems, virtual machines, everything you need to do one after the other to have something running. And that you need to plan. Otherwise, because this is not done in just a second or 5 seconds, you will not be ready for the show. Then again, what we see here, configuration, connectivity, that's pretty much what we are familiar with. Decommissioning things, finishing your event, costing and billing. When you digitize workflows, that needs to also use the same data you need to transfer from one team to another, from one step in the life cycle of everything you do to another one. So it's really about digitizing those workflows, what we always talk about, not only using digital technology. Once more, my 2 seconds, or 3 or 5. With the time in mind, I don't want to talk about each and every step and what we do. I want to talk a little bit about the deployment process. What we see, and we put it into 2 different buckets. You have those software media functions you were just talking about. Those can run on commercial off-the-shelf hardware. They can run in the cloud. They are cloud native. You can scale the way you want. You can easily migrate them from just any place, from on-prem to the cloud and backwards, and leverage existing IT technology and tools. But at the same time, you also see those multi-purpose platforms, I call them, often FPGA-based, but they are also dynamic in a way that one day you can run it as a multi-viewer, the other day it's a JPEG XS encoder, and then you deploy a new FPGA firmware, and you make it an ST2110 to SDI converter. So that platform you can use in a similar way that you use it here. You have those flexibility with the platforms. But you need to manage those and automate those processes. Otherwise, that deployment process probably takes forever when you do it in a manual way. Not sure, Dirk, how long did it take for deploying the Lavo platform for such an event? If that's a valid question.
Yeah, so we
just came to my mind.
Yeah, I'll come back. I'm not going to steal your time. So
okay,
I'll come back in the end.
Maybe a longer answer. But it's not done in a day, I guess. When we talk about deployment that goes together with planning and reserving, I want to bring up one point. You need to reserve the infrastructure that you need for the next event. And what is that? We talk about resources often. And what are resources? I want to bring it up for one reason. It's not necessarily the physical box anymore. A resource is, what I always say, like the smallest piece you can use independent of each other. You want to book something, you want to use it, you don't want to book the full box. If you have a camera, an asset, well, you use the full camera, you don't use parts of it. If you have multi-channel video server, as another simple example, you don't want to book the EVS server, the 4IU units for the event. You want to book a single channel, in or out or bi-directional. When you think about a network, you don't book the switch, you book an individual network port or an interface, maybe ingress and egress, because you need to book capacity. So that's something when you think about managing and automating those workflows and deploying and before reserving resources and your assets, you need to split up your assets into those resources. The same thing happens again.
But slowly.
That's a critical step when we digitize those workflows to say, really, you need to break down the assets into resources, virtual functions. If you talk about a microservice-based system, you have them already. This is like the smallest piece you want to use. If you use microservices, all good. But in reality, we have a lot of those assets still around, and you still need to split them. And then just a few thoughts. When you deploy something like what you have seen with Lavo, you do it for one event, takes multiple weeks to prepare, you decommission it again. Further down the road, and you have probably seen that white paper from EBU about dynamic media facility, you want to do this per production, very dynamic, not only for one big event where you have enough time and enough money in there. In an ideal world, you do it like every single day, multiple times. Manage your resources in a very much and more dynamic way. And again, automation is key for that. But just a few things why it's not as easy as some of our customers sometimes think, because there are a lot of dependencies in it. First of all, the resources, and it's very important, they don't exist at the time when you book them. A lot of people, they work with traditional booking systems where you have a list of resources. You say, I have 20 encoders, 20 cameras, 100 of those. That's it. But you can't work with this anymore because it's not fixed. You don't know what you have at the time when you book it because it doesn't exist. So you need to think about it a little bit. Same for the underlying compute. You cannot just say, I need 500 encoders. I need to see if I have enough compute. And depending on the encoder configuration, SDR, HDR, it might use more or less compute. It's not super easy to predict how much compute it needs. Licensing, a big topic, more important. Even if you have enough compute, even if everything is good, you might not have enough licenses. Do you have a central licensing server? Do we need to manage the licenses? Is it fixed? Is it very dynamic? Just consider it when you plan for those dynamic resources. And then also when you be out of the planning process, when you change things dynamically here, you have more inputs, more outputs in different formats. It has an impact on your VSM system, on the control system, because all of a sudden you have signals that haven't been there before, that have changed the format, they're not compatible anymore. That needs to adapt as well, that layer. It cannot be a fixed layer anymore. And last but not least, network capacity. Don't underestimate that. If you are in a non-blocking environment between facilities, if you add a lot of flexibility here, think about your network not to run out of bandwidth. So there's always impact when you try to be dynamic here on every single step afterwards. And when we talk to customers, and we have deployed a couple of projects, US customers, the large ones, they do pretty well in that, you need to start small. It doesn't make sense to do everything in one, try something out, qualify. This is what Lavo has also done. This Dell server runs exactly in a good way with this and this and this configuration. That's good enough. And later on, we do the next step, but not all in one. So dynamic resource management, key piece to automate those workflows. And then just one slide here. I love to talk about automation orchestration. A lot of confusion in the market. What I always say, orchestration is more than automation, more than scheduling, and more than control. A lot of people, they say, I buy an orchestrator, and actually they mean I need an IP signal switching engine, or whatever word you want to give it. When we say orchestration, we mean a framework. And the framework to automate the life cycle of something you do in your facility. That's for us when we talk about orchestration. It's much more using automation, using scheduling, and using control. Altogether, it's a framework, and very important here, that manages and tracks resources. Without that, you will be pretty much lost. And when you talk about resources, we need to keep in mind, and that needs a database underneath, the availability of resources. When I book resources, are they available? Yes or no? They are not available because I use them for my next event, but they're also not available because somebody has to do plant maintenance. That's the IT team. They need to use the same data structure, same database. Historically, I guess you did probably 1 or 2 updates maybe per year or out of season. Now when Cisco Arista tells you there is a security breach, naming any names here probably, any company coming up, you are forced to do an update now, not because you get new features. It's mostly about security lags companies have found. And you are really forced to do that right in the middle of a production. So plant maintenance, slots, which reduces availability of resources, you will see those more and more. So keeping track of the availability, capabilities, you need to know what the device can do because it's so flexible. When you run the Lavo example you just presented, you can do just everything. And you need to somewhere track it, what is capable, to be able to say, yes, I can do this or this or this. I have the license, I have the compute. And last but not least, capacity. This is mostly when we talk about network. And then we have an orchestration stack. And how to do that, talking a lot about what we need, I guess we need a flexible stack. We don't talk about products anymore, no matter if you go with data miner, our solution, or with anything different. You need a bit of a flexible stack that allows you to build things step by step, because you cannot achieve everything on day one. And in our case, a stack looks like that you have a data collection control plane interfacing with all your infrastructure. You take a copy of that, basically. You need to add administrative data. That's key nowadays. You need to loop in the schedules to know when do I need my infrastructure. Then you need a visualization layer. We call it data consumption. That's also more and more important to have the right user interface to simplify operations. As you said, Dirk, again, your example, the operators, they don't like complexity. They cannot handle that complexity because they are stressed out just running the show. You cannot tell them how to run and stop a Docker container. It needs to be as simple as possible. And then in the middle, This is key. You need tons of functions to run your automation, to run your workflows, to automate your workflows. This is not something which comes out of the box, because every operator, every broadcaster, every event is different, and you need to adapt. And this is work that needs to be done step by step. Start somewhere, have the right data in place, then start automating, do something good with the data, and visualize it in a way that people can still manage it. And what we have, we call it much more a framework. It's not a product, because there is no single product out there that does the job, and you always have to adapt. And adapting means you need to do it in a more agile way. What we have done, and that started during COVID, we opened just everything to our customers. We don't want to provide the services anymore for you, like a classic SI or a vendor. It's best when you learn how to do it on your own, because you're inside, you know what the workflow is. You're like your best agile team ever, because if you tell me to do it, there will be misunderstandings. We do multiple iterations. It just takes too long, and the bigger the groups are, the more chaos you produce. So no more waterfall projects. And when you go agile, you also need to have something modular in place that allows you to play with your data and to use the data in the way you want it. One approach we also did, because in the past, and that's, I guess, the case for many stacks or platforms, you had to be a developer to get something done. We see this a lot in the IT industry. It's called the democratization of software. You can now use AI to produce code. When I asked ChatGPT, I learned C# maybe 20 years back, I still get some code out. So that helps me already. Same for the user interfaces. I don't have to be an HTML expert anymore. We came up with, and we are not the only ones, a concept of low-code applications, which is a graphical user interface where you can use your real-time data, put together the building blocks you need, be it a routing panel or a scheduler, because I'm a different team, or somebody looking into the network. They all look at the same data, but from a different angle. So we're moving away from those one user interfaces or one software does it all, where you need training for 100 days before you can use it. Here we have small little pieces where you only get what you need for the next job. And again, those low-code applications, we often start building like a POC, a little MVP with the customers, and then they can edit this on their own, and then they can evolve on their own. Important concept to be successful in those more agile projects. Those are just a couple of screenshots. You probably can't see it much, but it's a graphical user interface. Key is always, you start with something, you start editing, it's graphical, you fine-tune, you publish again, you start operating, and we embrace also here those CI/CD workflows or DevOps workflows to say, I run it, I test it, I play with it, I publish it again. If I like it, it's good. If I don't like it, I can go back immediately. The undo function, which was it called in the past, that's key to have it. Otherwise, you are in big trouble when you do something wrong. And here, it's a good thing people really try it out. They fail. We say fail fast, then go back, and then you move on operating. And this is something the operators do. It's not engineering anymore. What does it mean? We need to educate operators. And they need to embrace a bit new workflows, and they need to be willing to learn. Certainly when it comes to the core software, more complex automation scripts to run a complete production with a single click, there is still coding involved at some point in time. This is something the engineering teams do. What we did there, as a company, we set up our own CI/CD platform. Everything we do internally is completely automated when we do coding, same for many other companies. But we also open that code repository in Git, in GitHub, to our customers. Big companies like NBC or Sky, to name a few, they use our CI/CD platform, or they even have their own one to do the very same thing. They code something, and instead of coding something and put it on the lab system and manually then copying it on the production system, it needs to be automated. So I talked a little bit about automation of the workflow, but automating testing may be even more important, because when you don't automate the testing and the changes you want to embrace in your system, you are stuck again. Because then it takes forever when you do a manual change. People don't know if things will break. If you only try it out on the production system, you need a proper lab system. and you need to use those ICT technologies, like a CICT platform, to test things out. And those are just, to wrap it up, a couple of example screenshots of those low-code applications for different teams to run something in your MCR, to run a production. It always starts with building resources. It's again a graphical interface. Don't look into the details, just to give examples, where an operator or an engineer in a company can build his resources. I talk about assets, then you need to think about how do I split my asset into virtual functions, do it on the user interface, and then you say, with another click, it's ready, I can use it, I can start booking it. And you connect it to the real device in that stack we were talking about. Then there are other applications. What can I book? What are the workflows I'm allowed to do in my MCR? I can do JPEG XS contribution. I can do a satellite uplink downlink. I can run a production in my studio. Those workflows need to be predefined. Again, graphical interface to say which are the resources from resource pools I can use, what can I book, and give those workflows, once I have designed those, to the operations. When they book something, they have a list of predefined templates to say I can do this and this and this and this, and the system knows what to book and how to connect it. This is again just a small subset of the data we have in the data lake, if you want so, to fulfill your role, defining what you can do in your operations. Scheduling teams, they work again with the same data. You need a scheduling overview. You want to say tomorrow from 10 to 12, I want to do this. I use a template. And from them onwards, you don't want to take care much anymore. And the automation kicks in, spins up, deploys your resources, connects them, monitors them, and runs and automates that life cycle. And lastly, and we are almost back, ad hoc operations doesn't go away. You still have the people. Not everything can be fully automated. They just do things on the fly. You change parameters. You need to loop in and splice in an audio delay processor engine because you couldn't plan up front. Certainly, you need user interfaces for that one. Use existing ones, build your own ones again, and all together, this is always important. It's not only about technology, what we are talking here. You need to pick the right technology. This is the foundation. It needs to be open, it needs to be flexible, data-driven, things we have seen. But also give time to the teams, to the end customer to learn this technology. Something we tell during every single project, it's not us offering 200 days of engineering services. We better offer 50 only and spend 100 days to educate the team. And then they can move on. We really need to move away from those waterfall projects and turnkey projects. Agile methodologies, this is key. And empower your people, give them the right tools. I cannot expect everybody to be a developer, and give them those low-code applications. Give them things where they have a realistic chance to learn and to be motivated to really use that technology. We see companies, they focus on technology only. They're pretty much stuck after a while because they just changed technology. They didn't look into the workflows. They didn't bring the operators on board. Those are not the most successful projects, but when you really onboard the people, give them time, and that's an investment you need to look into, then those transitions to IB, I guess they can be really successful, and we see it with successful projects out there nowadays. It's not just that we talk about theory, it happens right now. Almost in time.
That's okay.
Thank you very much.
5 minutes for some Q&A, if anybody would like to have any questions. Anybody have any questions? We have about 5 minutes. We're just back to the dock.
I'm still waiting for the answer.
Oh, for the answer.
Yeah, how long did it take?
So the deployment, we pre-configured the server stack in Germany, so at Labo headquarters, and then we actually shipped it out. The pre-configuration was done, I would say, the server stack was done in 1 day. All of the gateways from all the stadiums, the pre-configuration, I would say, took like 2 days. In total, the team was working there for like a week, to get everything pre-configured. And then when it was shipped on site, we even didn't see the kit anymore because it was completely spread out to all the venues. Our team went there, but on such global big events, you need to be there like 2 weeks before. Yeah. Spinning up all the processing and spinning up all of the things really is done, as already explained here. It's fully automated. It's one click on a button and it actually spins up. So it's a complete different mindset. It's also a complete different time that you need to configure it compared to solutions we had before. So, yeah.
Does this include physical construction as well?
We didn't do the physical installation ourselves. Yeah, that was done by the customer. So we provided them with all the gateways, and they then put all those flight cases together with all of the master clocks, the network switches, the cabling, all of that. So we didn't do that. Yeah.
Thank you. We did a reality check.
Yeah. Any other questions for? No?
If you'd like to stay for the next session, you're welcome to stay on board. And if you'd like to disembark, then enjoy the rest of IBC. so we will have a little bit as we back out. But if you can't hear or anything like that, please raise your hand. We'll have 2 speakers. They will speak for about 20 minutes. We'll have 5 minutes for Q&A, and then we will move on to the second speaker. And basically, when the boat turns around, that's when you know you're going to get your second speaker. So you need to be done by the time this boat turns around.
All right.
Okay.
Okay.
All right.
Well,
Let's get underway.
Yeah, thank you very much. Thank you very much to the IP Showcase for giving me the opportunity to talk and kind of share what we've been doing at Dolby and our partners been occupying us for the last few years. I've never presented on the move before, but it's good because no matter how bad my jokes are, you're not going anywhere. So, right. Case in point. So, serialized ADM in 2110-41. Okay, so this talk is I've not done this kind of venue forum before, so I'm kind of assuming I'm going to start right at the beginning. So I know it's going to be boring for a few of you who are really kind of familiar with this topic. Hopefully I'll be invited back. We can go into some more advanced topics, but we're going to start at the beginning for now. So problems with audio. Okay, we made a lot of progress with audio, but the reality is that a lot of the problems with television audio are still with us today. There's poor personalization choices, the accessibility choices. When they do exist, often they're given a presentation which is inferior to the main presentation. And things like headphone, all you can get is stereo. You know, we can do better than that. We have the technology to do better than that. It's just a matter of the kind of delivery and getting the pipes ready. Okay. So NGA, I just want to explain the kind of basic concept of NGA, next generation audio, what it means. It's a kind of umbrella term for lots of different things. We've got immersive, so Dolby Atmos. You know, this is already with us today. It's been actually live for quite a number of years. The other areas like personalization, accessibility, these are more kind of nascent and emerging. In terms of devices, it's about trying to make sure there's a not consistent experience across devices. That's impossible, but that the experience translates across those devices and it's meaningful to the user, whether it's headphones or a 714 speaker system. Okay. All right, now there's a bunch of technologies that need to come together for us to go down that kind of NGA road. And there's lots of things we could do with NGA. You're here with NGA, lots of kind of crazy stuff, ideas. I mean, lots of things are possible, but what we are focusing on really as a first step for broadcasters is separating out the music and effects from the dialogue. That gives you multi-language, it gives you accessibility, it gives you dialogue enhancement as well. So this is just, it's a single change, but don't underestimate the simplicity of it. This is a big lift for all the organizations involved, but in terms of the effort involved and what you get back for it, it's a really good trade-off. So that's where we're focused, and there are obviously other things that you need to enable that. We need IP to get the channels that we need metadata, and we need a codec to get it to the consumer.
You hit the mute button. There's an optical mute button.
Okay. So, what does IP give us? Well, the two things you need for next generation audio, we need more channels. We can't do a whole lot with 16, and we need metadata. Okay, so first of all, in terms of channels, so when SDI, 3G SDI, and the 32 channel addition was made, this was actually a big opportunity. Would really be helping us out now, but the reality is the devices are not there. We're limited to 16. We assume that is always going to be the case. Really, with 16, it's kind of, there's only so much you can do. With IP, it's, to all practical purposes, unlimited. because you can associate multiple streams together. So, and NDI also has a kind of, to all practical purposes, unlimited channel count. Okay, so how would we use our channels? Well, it kind of depends. You've got legacy services. Often people want to do simulcast and they want to include legacy stuff as well. You 514 M&E, music and effects, so it's that separation we need to do, and then adding on the dialogue tracks as well. And maybe there could be metadata in there as well as the legacy. So you can see how you burn through the 16 very quickly, and some organizations want to send more than one effects bed, maybe for rights reasons. And NBC have certainly cited that. So with that, with 514, you've blown through the 16 channel straight away. So really, with IP, we've solved the channel problem. So what about the metadata? Well, there's been a solution in place for a very long time, ADM, the audio definition model, standardized by ITU 2013. Dolby has been using that for many years. So we've got a data model that's already good and can be used we can use that in broadcast in the way that it's been used in post-production. So serialized ADM is really just a frame-based version of that. And there was a need recognized at some point, okay, yeah, ADM's great for file-based workflows, but for streaming we need something different. A lot of standardization work has gone on, getting it in the various transports and also in file-based formats. Okay, and it works in new IP workflows, which is what 2110-41 is all about, also in legacy as well. There's the concept of profiles in ADM generally, but that serialized ADM uses the same, inherits that same data model. That's where you would have one set of audio for you in production, where typically maybe you'd have a large number of objects or channels, and then something that is used around a facility where you're feeding an encoder, like maybe for linear playout and so on, something which is much, much simpler, much saner, much closer to what we've been using in the past, but with that enables the new features as well. So something like a 514 plus 2D, 2 languages plus AD, something along those kind of lines. The emission profile is standardized by the ITU. It wasn't published in spring 2024. There's kind of political issues at the ITU. Nothing's been published, but it is frozen. Everybody is using it, and actually if you get an ADM file and you put it in media info today, it'll tell you whether it's compliant with the draft standard. So it's already, you've already got tools out there everyone can use that are free. So how in practice, like this serialized ADM, how does it kind of get on the wire? Well, it depends a little bit on the transport that's used, but it's basically the same idea in most cases. You take the ADM, which is the description of your audio, tells you what you've got, plus extra stuff like loudness, downmix parameters, whatever. Could be object locations as well. Then you add in a transport mapping to map those various audio elements to your tracks, your physical audio tracks. So that creates another bigger XML, which is then compressed normally using just a simple gzip compression. And that's placed repeatedly on the wire, typically once a video frame. The standard doesn't specify a repetition period, but once a video frame is just what people generally, we've seen they've gravitated towards doing. So one question that I often get up is, okay, this SMPTE 2110-41, why didn't you go with SMPTE 2110-40? So there are a number of reasons for that. Really, it's mostly down to the kind of legacy that comes with SMPTE 2110-40 and limited bandwidth. And so I think it was Paul Briscoe that started the work way early on to try and take care of some of the classic like VANC type applications. As time has kind of gone on, it was recognized, hey, there was work going on in AES, and that was combined with the work going on in SMPTE to use it as an application for audio metadata. But it's not limited to audio by any means, and in fact, Dolby is using it to carry video metadata for Dolby Vision as well. I'm just going to talk about audio today. Yeah. So in terms of the basics of 21-41, it is kind of pretty simple. There's an identifier which tells you what you've got. It's just a number. And there's one defined for, not for serialized ADM strictly speaking, it's for what's called metadata guided audio. And the reason metadata guided audio, which is kind of extra layer on top, is used is because that is used in MXF. So it's the same concepts being used in MXF as well as in SMPTE 2110-41 to enable easy kind of transfer between live and file for play out and so on. So in terms of standards, yeah, we got 21-41. That was published in March. Thank you to all the folks at SMPTE, John and others making that happen. We've got 2127-2, which specifies the mapping of MGA, which includes serial ADM, into 21-41. That was also published at the same time. And there's also actually another useful standard, is 2116, which tells you how to put serialized ADM into a 337 wrapper, which could go on AES3 or SDI and so on. So useful for legacy workflows. And it's really been a collaboration effort. This is not a Dolby thing. It's not, we have a stake in it, but we don't own it in any way. And in fact, it's been a number of organizations that have contributed to this to get us to where we are today on a standards position. So given that we can put it in SDI and AES3, one way to put it on IP would to be use transparent AES3 in SMPTE 2110, i.e. 2110-31. So why not do that? Well, there are two reasons. One is, okay, then you're putting the metadata in the audio channels and you need all that bitstream detection and all the logic around that. It's a pain. I've seen services go down because of this stuff, getting it right. It actually looks trivial, but it's not easy to get right on a 24/7. It's much easier if you're dealing with a native IP stream and you don't have to deal with the frame rapidity and the sync words and everything, all the complexity that deals with that. Also, the signaling is not explicit. In the SDP 21-31, all you know is it's AM 824. You have to start digging into the data to figure out what you've got. With 2110-41, you know you've got MGA. You can look in just at the STP and kind of figure that out straight away. So it keeps that separation between the control and data planes. Okay, so case studies, like who's been doing this stuff, who's looking at it, right? Two I'm going to highlight today, but the most important one is the Paris Olympics, and this was really a watershed, I'd say, for the whole kind of technology. It was, and actually I'll go into that in the details of that in a minute, but we also earlier on, we worked really closely with SRF, the Swiss German broadcaster, kind of fleshing out the ideas and testing things with proof of concepts and early versions of software, whereas on the France side, we're using real products from a variety of manufacturers, actually some of which are represented here. So the France TV case. So what's important here is we've got our feed coming from OBS, and there is a dedicated serialized ADM authoring unit produced by Younger Audio, and Roman is the product manager. He's sitting there at the back on the right, so you got any questions about that, ask him. But there was a unit there describing the feed coming in from OBS. Then there was another Younger unit downstream in the facility, which was describing the feed coming from the linear playout, the automation system. And there's a switching that occurs through the control, master control, which then switches between the two sets of authored metadata, along with everything else, the audio and video, driving the ATEM encoder. So the ATEM encoder doesn't care too much about what's going upstream. It sees the metadata changes, and it uses the new metadata set and reflects that downstream. So mostly it was about switching between 514, 51 stereo, that switching rather than the personalization or accessibility features. But, you know, the plumbing is all there. They've proven a lot. They're very happy with this workflow. It worked very well. So they're now looking at, well, what else can we do with this? Looking at those new features. Yeah. This, I'm not, the SRF was a couple of years ago. This is not so important now. It's complicated. I'm not going to go through it. I don't have the time. But the key thing we learned out of this was, one, we could get the streams across infrastructure that already existed. Two, that the concept of authoring upstream in the venue and then reauthoring within the facility, having the ability to do that, because everything's metadata based as opposed to being baked into the content itself, was really valuable to broadcasters. This was something they wanted. It could be giving the broadcaster downstream the ability to remix content if they so desire to do so. Okay. So with the France TV, and then also Canal Plus is the next one. They are just embarking on a big, very ambitious project, doing both live and also file-based workflows with MXF, with serialized ADM. So between these kind of projects, this is driving a number of manufacturers to get involved. This is not an extensive list by any means. In fact, I know Emotion Systems, for example, they are starting work on serialized ADM immediately after the show, and I expect there are others I missed. This is just to send out the message, hey, this is not theoretical anymore. There are people putting real money on this. Checks are being signed. This is real. It's not theoretical anymore. Oh, also, if you have the time, come by the Ravenna booth, where we have a couple of products, the authoring unit and rendering unit from Younger Audio, the AI Expressor, and Bridge Technologies VB440, just showing a simple kind of chain, and you can see the user interface. We can talk you through how those products work. It's in Hall 8, so quite close by. I'd be happy to help you if you want to kind of know more. So, what kind of, think back to the problems I talked about at the beginning. How does serialized ADM, what does it give us that's kind of useful? Well, the M&E support, that gives you a lot of the kind of personalization and accessibility options that you need. Having bed and audio gains allows you to do that dialogue enhancement, so have a presentation maybe where dialogue is louder. The logical copies of audio elements, I'll come to that, well, that's kind of useful. But there's, of course, a whole load of stuff which broadcasters are not thinking about now, but it's possible in the future. I think perhaps the most important one is binaural metadata. Okay, how are we doing for time? No, okay, 1 minute. Right, this is something we worked with at SRF, and if you want to do 3 languages, 3 complete mains, 5-1, okay. 6 channels each, you need 18 channels. Bang, you're straight through your 16 channel limit. Okay, but if you split everything up and you have your 5-1 bed with 3 dialogues, you send the metadata and you actually do the mixing downstream, that actually saves channels. And they saw this as being really useful because the reality is a lot of those pipes, they don't change quickly. But this is a way to kind of get more down that pipe or save money. Okay, so one thing, a lot of people, NGA, they all this stuff and they say, well, what's the killer app? What's the thing that's going to move the whole industry forward, right? Like, what is it, you know, as if there's some magic thing. The reality is there's no silver bullet, there's no killer app. You talk to the various broadcasters, everybody wants something different. They've all got different problems to solve. The key here really is the flexibility and agility that the system provides, that it could be kind of something different for everyone. And it gives you the ability to dream, i.e. there's a problem that we haven't thought of that it will solve for you. So we're not solving for one particular thing, we're solving for a whole group of things, but also about the things that we haven't even thought of yet. Okay, thank you very much for your attention. Open the floor to questions.
Anybody have any questions?
Yeah.
Oh, you want to record that?
Thank you. Yes, please.
Okay, do you see the final mix as something that is actually being mixed at the desk, or is it metadata to be added to the stream so that the raw M&E plus D and the dialogue goes to the end user and the final mix occurs in the presentation system?
Yeah, we don't want this to change the way that creatives work. If you work with Dolby, you'll know that preserving creative intent is really important to the company. It's for a long, long time. So with the metadata, it's a lot about preserving that. But with this system, you can capture the artistic intent, but you still have the opportunity, for whatever reason, to then undo things. It could be that things, you know, there's a QC system, or there's a need to adjust things, kind of downstream for whatever reason. And I think the conversations I had with broadcasters, they would like to have that, even at least having the visibility of what was done, right? And being able to kind of check it, get statistics about it, rather than just baking everything into the content.
So I'm going to ask what I think was actually Dave's question differently. Maybe it wasn't Dave's question, we'll see. A lot of the features of NGA, like accessibility or choose your own language, that sort of thing, are really consumer features. They're features that, you know, you might want and you might not want, or you might choose differently depending on the individual consumer. How does this, you know, smorgasbord of, you know, the M&E plus D and so forth get delivered all the way to the consumer? You know, this is all like, how do we get it through contribution? How do we get it through studio? What's the consumer end? How do we get it to the consumer? Do the delivery platforms have a path to supporting it? You are right.
Oh, yeah. Yeah, so the important thing for, like, if you're talking about M&E plus D, is to use a codec that can take that as input, right? And that really restricts you to the kind of NGA codecs. I would say that's Dolby AC4 and MPEG-H, right? If you restrict yourself to just the immersive portion of NGA, so then you're talking about 514 or something like that, then you can add DD plus to that. So, which is really, at the moment, that's the kind of standard for immersive. But if you're talking about, okay, now we want to make the step from just immersive and we want to provide that dialogue switching or the dialogue enhancement and so on, then you have to make the step for the codec from DD plus JOC to AC4. And obviously the consumer devices have to be equipped with all the apps and so on.
Perfect timing, we're turning around.
Why is the emission profiles must be different?
Well, from the production profile. Yeah, the reason is really with emission profiles probably be a function of the organization and their practices and how they want to organize things. Whereas the production profile is more about the actual content and the way the content is produced, right? So it's impossible to restrict all your content to be produced the way a particular organization wants to rationalize their content. They want to get consistency across content. So by that, then you end up with this kind of two-step approach of having, so for example, Dolby Atmos master profile, this has up to 128 objects, right? So, but we don't want to say to everybody, oh, you've got to carry 128 tracks of audio through your facility. This is nonsense. This is not practical in the near term. So you have to then decide on a format which is simpler, but doesn't degrade the experience to the consumer. Does that make sense?
So it's improve compatibility between different organizations.
Yeah, because the different content may be produced using different profiles. Yeah, we would love everybody to use the Dolby Atmos master profile and that, but the reality is that people are probably, there's an MPEG-H production profile, right, for example. So.
Thank you very much. We appreciate that, James.
Thank you.
Get our Q&A mic back up here.
What? Okay. So I'm John. I'm going to talk about the other half of the problem, which is on the production side of the world. So in distribution, we've got, these nice, 5.1 plus 4 blobs of audio. All the channels go together. Everyone has a written down list of left, right, center, whatever order it is. But if you've ever worked upstream in the production world, you recognize that sometimes the producer just says, I want the left channel from camera 3 to show up here. And it's not a negotiation. It's not a, well, let me think about that. It's a, yes, I'm going to go click, click, click and make that happen. And why? There's no why to some of these things. It's because it's wired wrong elsewhere and you're fixing it or whatever. And this is true usually in the front end of facilities. Either you're getting signals in and it's just not lined up the way your plant lines up things, or maybe it's a production environment where that microphone that's on that person's belt pack is coming in through channel 7 of that thing, and you just have to pick it up and get it to the sound desk. There's no rhyme or reason. They're just mono channels. So how do you deal with this need that does really exist to deal with mono-channel granularity in this world of 2110 where we tend to have a lot of multi-channel streams? That's why we're here today. Now, I don't have to tell you, you all seem like people who've touched audio, that audio is always the problem. Every project we stand up, the video is working on the first day, and then we spend the entire rest of the install screwing around with audio. Am I overstating that?
I have no idea what you're talking about.
So, like I said, the back end of the facility, play out, master, audio's nice and arranged, but that's because upstream, somebody went to the trouble of arranging it, and that's the side of the problem we're going to talk about here. But even when it's usefully perfectly arranged, sometimes you have to fix it. Sometimes you have to just, arrange it in the first place. So all that said, IP didn't make this problem. This isn't a new problem. IP may have made it more, you can do more things, so now you can do them in a more complicated way that's more prone to errors. That could happen, now that we have more audio to mess with. But in any case, in IP, is IP here to help us? Is IP here to hurt us? Or is IP just a fellow passenger? Well, in IP, we tend to organize the audio into streams. And that's AES 67 says you can do a lot of different things. It tells you if you do this, how to do it. It doesn't have too many requirements on what is a given receiver's, what does this generic receiver have to eat. That's actually a really small list. But in any case, in our control world, ISO 4 lists those stream receivers and senders. ISO 5 lets you connect streams. That's all good, right? But if you want to manipulate at that mono-channel level, if you want to say, I need channel 3 from that stream to show up over here at this frame sync on channel 7, how do you do that? Well, you don't do it with ISO 5. So how do you do it? Well, ISO 5 and 4, they're just about streams, moving streams, switching streams. If you need to take a mono channel, how do you do it? That's ISO 8 was invented for this purpose. So that was a long discussion. ISO 8 came along a little later. These numbers are issued in order, so there was a 5 and a 6 and a 7. And ISO 8 came along as the part of a solution to solve this problem. And I could argue that it's an imperfect solution. That's a beer argument, but I could talk about why I think it's an imperfect solution. That might be a Q&A topic. But it's the solution that the consensus body AMWA came up with. And it's fine, and I've sworn to say it's great. But anyway, it's okay. The funny thing, ISO 8 is a public API that lets you tell a receiver what to do after the receiver. So it gives the ability for an endpoint device to represent usually there is some kind of audio matrix between the receivers of streams and the consumers of channels inside. And most devices have that matrix. Most devices have a handful of stream receivers. You can imagine being able to control that matrix in an organized way would be helpful to this problem, and it is, and that's what ISO 8 was for. Now, we do have some customers that took the opposite approach and said, well, I'm just going to make every mono channel a separate stream. And if the equipment you have supports enough channels that you could do that, and it does work. For some value of work, it is a lot of work because you have to configure all those streams, you have to manage them. Every time you hit take, a lot of stuff tries to happen, but it does work in the sense that you get that mono granularity using ISO 4 and 5, and there are production systems that do that. There's also ones that use, take the middle ground and make every stream stereo, and they do the shuffling at stereo, and that actually solves 90% of people's problems, maybe 80, maybe 90, in there somewhere. But, you get a lot of receiving devices if you buy I'll blame tech. You get a Tech Prism. It used to have one stream receiver, now it has 2. That's an upgrade. So it can take 2 8-channel streams, it's really happy doing that, but it's not going to take 16 mono channels that are all separate. It's just not how it's done. And that's true of a lot of devices that are actually, in practice, things you can buy, is they are not designed around the idea of having a whole lot of separate stream receivers. They have 1 or 2 or 3 or 4, but not 16, right? So, and not more than 16. Like if you needed your, D plus M plus a bunch of, or M plus E plus a bunch of dialogues, you run out of those 16 even pretty quickly. So, that's, you could, but most people don't. Now, what does it mean when you route streams? Well, it means I have maybe a playout system that's got a 5-1 mix and a stereo mix, and when I route those things here, I route those things to maybe the other MCR. I can make a switch. I can do a breakaway where I take maybe one video and different audios, but that breakaway is at the stream level, right? So, sorry, I can, you know, oh, that's, yeah, you've got a very impaired view seat there. So the breakaway is at the stream level, which, you know, in a playout center, maybe that's actually what you wanted. That works. I mean, a lot of systems are built this way. But you don't have a way to express taking a channel from here and doing something special with it. So if you know, ISO 5 by default routes streams, logical streams. But how do you integrate things that aren't consistent? Suppose you have, you know, a pair of 8s and then you have those mixes. What are you going to do with those? How are you going to map those? Because things, you know, things happen in production. You get the last minute signal comes flying in and it's not organized like you wanted and it's too late to fix it, and you know, shows in 3, 2, 1, you know, you gotta do. So the idea is you'd really like to do track routing, meaning you route the streams and then you control this mapping downstream from the receiver into the actual channels, which as a router user, if you're punching the buttons, your destination in your head is not the stream receiver. The destination in your mind is that channel down there. That's really what the operations team expects, because when they buy an SDI router today that's got audio demuxing on the way in and audio muxing on the way out, and it's got 16 levels of audio, and they go on the panel, that's what they're doing, is those are the destinations. These are not the destinations. So how do we get to where people get what they want or what they expect out of the tools that we've been building as an industry? That's where this ISO 8 comes in. If you can control this map, then you can implement this feature from a control standpoint. So that's what you want. So for a device that's enabled by ISO 8, the controller can use ISO 8 to manipulate that map. And then if you want to take, you know, a couple of channels from here and do something crazy with them, you can do it, because the control system can route the stream, route the channels, and deliver the route that you asked for with a mono-channel description. It's all well and good. What about, you know, do you need ISO 8? Could you do this without it? Well, yeah, if there was instead like a different API on every device like we have today, and you write a lot of drivers, and, you know, as somebody in the control business, like, that's work. Customers hate paying for drivers. We hate writing drivers, honestly. It's nobody's happy with that model. So that's why we need standards, standardized APIs, and that's why ISO 8 as a common API can solve this problem. Now there's a secondary issue though. There's devices that don't support ISO 8. Well, let's talk about the ones that do. So the ones that do, the control system can manipulate the map, it can route the streams, you can deliver mono audio. And you can route, you know, all the way to those destinations straightforward. But what about, okay.
Marching practice.
There really is, okay.
Audio marches on.
People who watch the stream later are going to wonder what just happened. So we talked about earlier devices that don't have a lot of stream receivers. And this is a challenge, because even if they supported ISO 8, if they only have 1 or 2 stream receivers, at best you're just going to shuffle channels that are already there. You don't have a way to say, well, I want to add this one rogue, you know, commentary feed or something into there, because there's just not a third receiver. So devices that don't have very many receivers, or frankly devices that don't support ISO 8, I prefer them as devices that need help. How do you help a device that needs help? And the answer is, well, you wind up needing a helper matrix. So you wind up throwing in some, you know, modest-sized, hopefully, audio matrix that the control system has to, you know, build the streams for this by taking in the right streams here and doing them shuffle externally. And people do this. A lot of networks are built this way. This is actually not an uncommon methodology, because it works around the things that either don't support a common API or don't have a lot of stream receivers. And both cases exist in the wild, and I think both cases still get produced in the wild. Like these are not legacy problems, these are still ongoing problems that the industry, we built all these tools, they're very flexible, they can do a lot of things, and you could build a lot of different equipment. And what we haven't developed as an industry yet are the common practices. We have standards that say, if you do it this way. But we don't yet have a lot of common practices that say, generally people always do it this way. And then people build equipment that implements the common practices. We're getting there, but it's like something that we just learn as an industry. If you think, well, no one here is old enough to remember when SDI started, but it was the same kind of, oh, yeah, me too. But it's the same thing happened then. I'm sure the same thing happened in the 50s with color, right? There was a Wild West period, and then people settled into a workflow. And in 2110, it's the same way. There's been a little bit of a Wild West period early on, but here we are in 2024. We've settled into some common workflows, and this is quickly becoming kind of the how we deal with things that need help, and ISO 8 is becoming the how we deal with things that can do it on their own. And the more things you have that can do it on their own, the smaller your helper matrix can be, because it's supporting fewer and fewer downstream things. So practically, as a controller, you have to do both. You have to support the things that need help, but you can use ISO 8 as a common API to deal with device, to directly route to devices that can support that. So what's the status? Well, this ISO 8 is done, finished. In AMWA speak, we call that stable. We realized early on in AMWA that while we continue to improve some documents, and they have little dot versions and so forth, we also have a tag called stable that says, this one's done, this one's stable, you can count on it, you can build equipment around it. So ISO 8 is stable, it hasn't changed in a number of years. But, and when devices adopt it, that's all good. By the way, AMWA specs are free. I mean, free like free beer? No, they're really free. So there actually is specs.amwa.tv, has all of them, and you just, there they are, click, click, click. You can get them on your phone right now. But so as devices adopt it, that's great. But what's the real state? How's it going? Well, it's a little slow to catch on. And I think it's a chicken and egg problem where on the controller side, there hasn't been a huge demand because a lot of the controllers had drivers for things and it just wasn't like really big yet. But also on the device side, it's been a little bit of a challenge. And there's a little bit of a nuance with ISO 8 that it doesn't provide timely status. So if one controller makes a change through the ISO 8 API, there's not really a timely way for anybody else to know that happened. And that's an actual design problem in ISO 8, and that's kind of the discussion topic for the Q&A is there a way to improve that? Is there a reason to improve that? And is there enough willingness in the room for people to actually work on improving it? Because all of these standards and specs and things are developed by committees of the willing. People say, oh, AMWA should do this, but AMWA is just folks like us, right? And without folks like us that actually turn up to a meeting and do, nothing happens. So that's sort of my punchline of this is ISO 8 limited because of the status challenge? Is it limited because of just industry getting there? Is it a COVID hangover we just got to get over? Maybe it's all three, but I leave it to questions and comments. Okay.
Anyone have questions?
Somebody. No? Okay. She's still got to park the boat, so you see. And by the way, eat the cookies. They're here for you.
Eat the cookies, please.
So is there any way of identifying the content of individual channels within streams? So you showed us the ISO 8 and how that allows you to potentially use a submatrix to select individual flows or individual channels.
Yeah.
But in terms of putting some context-sensitive metadata against each stream.
Well, you're asking the question, but so in 211030, we added these audio channel labels, I think we called them. And it was an enormously long, convoluted discussion to even think about nomenclature for those. Wes will remember that one well. That was several weeks of everyone's life. And they're optional at the end of the day because a lot of times equipment doesn't know what the channels are, right? So if I'm responsible for taking an SDI and turning it into 2110, it's a very common use case, as a device, I have no idea what's in those channels because nothing tells you on SDI. And sadly, that's caused us to propagate the uncertainty. So there is a nomenclature in the SDP to at least identify the channel ordering within a stream with some labels that might indicate what they are. But in practice, it's unusual that it's filled in. And unfortunately, there's also some devices like encoders I've seen that expect it to be filled in and refuse to encode the audio properly unless it's filled in. And that's been a challenge also. But I think those all got fixed, but there was a period where that was also an issue.
Yeah, we use a sort of a routing plane that's above the basic routing plane, and we identify all the streams with language tags and type tags and things. And I think the eventual dream would be to get some of that back actually into the stream description,
and
so that you've got some context within the actual flows.
Yep, and I think there's certainly devices where you can push that data down and it shows up in the SDP, but it's like work, right? You got to do it.
Yep.
Well, at that point, you've got to manage your nomenclature as if it's a router database on a source-by-source basis. So it would seem like that's really problematic because it becomes dynamic. It's very different coming from a stereo source versus a mic or two plugged into a camera versus a 5.1. There is no standardization of within any stream, channel 1 is always this and channel 3 is always that. Absolutely. Especially in a production environment, it's literally different on every single logical source. So it almost requires it not to be, it needs to be fed into the SDP from the router controller because that's the likeliest place, and then it needs to have aliases out of a TSL or something like that on a production by production basis. So it actually gets, it probably can be done. I'm thinking on my feet as I go here. But there's a lot of moving parts.
Right, and one of the challenges with the channel order descriptor, it's called in 211030, is that it's actually required. And yet, as a device, if I have no idea what's in those channels, the worst thing I can do is label them as, oh, this is left, right, center, blah, 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 with no idea if that's true. Because now I've created a truth that's not really true.
A broadcast service panel in the studio has no idea what is plugged into the XLR jack.
Right, exactly. So, but as a device, I'm required to put a descriptor. So, like by default, for several years, we put a descriptor that says unknown 8 channels.
Yeah.
And that's what you see in almost everything is unknown 8 channels. Because if you require a device to mark something, but it doesn't have the information to actually mark it correctly, the worst thing it can do is mark it incorrectly in a language that looks correct.
And it could be multiple names for one service as well. It could be receiver 1 for one person, and it could be English mono mix for another.
Yes.
So
yes, that too.
That's why I was saying the aliases.
Yeah, unfortunately, the meaning of the channels is up in human space. And several layers down in these APIs, the meaning of the channels isn't known by the devices that are making those APIs.
Exactly. We define it in human space.
Yeah.
That's where it stays.
But that's why the SDP, the source device can't create the SDP. The broadcast controller has to probably modify it because the broadcast controller is the interface to the human level. Either that or the tally system that's putting up the UMDs and feeding channel names to the mixing desk.
Yeah, although it's rare that people propagate meaningful audio names into the tally system today. Maybe in the future.
It's actually,
is it?
It's starting to happen.
Okay.
Cool. On the channel labels in -30,
yes.
If that was to become more important and in systems, could we have immersive formats? There's a huge problem with a plethora of different immersive formats.
If you'd like to start a project in 32NF to enlarge the universe of channel labels, that would be an easy thing to do.
Okay, not me, but I know a man who...
Oh, Kent Terry would carry that sword, yes.
Not Kent, but someone else. Yeah.
Okay.
Okay, that'd be great. I'll take that up.
Loop us in because we'd be very interested.
So in your example, you're talking about the mono sources which might be in the wrong place on the stream or want to reshuffle. It's not so much that left and right is swapped or something. So I was thinking, why wouldn't you treat a mono source like a mono stream, a one-channel stream? Because since it was once one XLR put in some like a microphone, and for some reason, and I can understand reasons, but channels are combined, like an 8-channel stream or whatever, and now we're trying to solve the fact that they are combined in one stream, but there is enough capacity and timing and timestamps and whatever. So
you could build a system with mono-channel streams, and some do. The real challenge is if you've got a mix of, you could make things that are mono-mono, things that are stereo-stereo, things that are 5-1, 5-1. The challenge becomes in the receiver side, how do you marshal those into the places they're supposed to go? That's really what the APIs help. So once you solve the receiver issue about pegboarding those streams, then you can deal with the universe of, a mix of monos and stereos and whatever on the source side. It actually is enabled by fixing the receiver end.
Yeah, so the receivers like a mixing desk or intercom, whatever, should by design have multiple stream receivers in order to accomplish the capacity it would provide.
Right.
But
Well, multiple stream receivers and the ability to control the shuffle. Yeah.
The vast majority of the vast majority of receiving devices by default have 4 receivers, 4 audio receivers per video. There are some with 2, there are some with 1, there are a handful with more. So if you want to get 16 or 32 channels in, you have to aggregate into that number of receivers. Either that or people have to rewrite the firmware that's driving their NICs because there's a limited number of IP sockets. So that forces you into aggregating into the streams, which is illogical from a production standpoint completely. But it's where we are in hardware right now. And the other thing that happens is in a large production facility, actually now distribution with immersive, you could end up with 40, 50, 60,000 multicast streams if you're doing mono channels very easily. And that now complicates what the switches have to handle. It makes your salvos operate slower because now they're switching massive numbers of streams. So it's not, you are in no way wrong from a production standpoint. You are absolutely right. But our limitations are in several places in hardware and base software now. So I have to guess it'll be a while before we can get there, and these are all compromises in my mind.
Yeah, but it's, as an industry, it is about getting there, and that's like why I talk about this topic today, is because I'm trying to stoke the discussion of how do we get there, can we build some more, demand for devices to be a little smarter on the receive side so that we can actually use the APIs we've defined to do the work that we're all trying to do.
If you could make a wish and design.
Are we trying to wrap or are we done? Okay. Okay, sorry.
Design from the ground up and say, okay, I can dictate the whole industry. What would be your what would be your vision? Would the vision be single mono channels everywhere and every device will support this, or
no? I think that trying to have a lot of mono channels in the network complicates the network significantly. If you look at the new crop of sort of Pro AV switches coming from Netgear and people like that, their main sort of way their spec is different from the really big Aristas and Ciscos is the number of concurrent TCAM entries, the number of concurrent multicasts. So that is, not a direction that's, plus Dave's point about the, salvo quickness and things, it's a transaction volume challenge when you're switching. So if I gave advice, and I'd have to make products, so I have to give advice to my own team, it's to have some more stream receivers on devices and expose that matrix so that a control system can actually use it. And I think that gets you to where more of the stream shuffles and one-off mono stitchings can be accommodated in the devices you have, and then just have that little helper matrix for the handful of things that don't have enough receivers or don't have controllables. But making that workflow work and be more installable and more usable is kind of where I think we're going to wind up as an industry. That'll go from being a feature on some systems to a feature on most systems.
Thank you.
Right. Anybody else? Nope. Oh, okay. One more.
Does the 08 deal with? Is it just purely kind of the matrix routing at just after the receivers, or does it also deal with the kind of the 05 subscriptions as well, or does it has to be an 05 followed by an 08?
It has a way not to, but everybody I've talked to about it tends to associate the channels to the stream receivers because that's what the controller has to understand. In principle, 08 could probably model like an SDI input and how you take its channels, but I've never seen anyone implement that, and I've never seen a controller expect that. Now, ISO 8 also does have a way to describe the back end of a device, how you marshal the channels into the sender, but I haven't seen anybody use that either. I think usually that's set up kind of statically, and then it's the receiver that needs the dynamicism.
We are at time.
Oof.
If you have a registration,
Eat more cookies.
reservation for the next cruise, you are welcome to stay on. If you don't, we're going to ask you to disembark.
Okay, all right. Thank you all. Thank you very much. Thank you.
I'm Tina Lipscomb. I'm the operations manager for Ames, AMWA, and BSF. So if you ever need anything for any of those, I'm your person. We'd like to thank you on behalf of all three organizations for attending today and taking an hour out of your time. We will be leaving the dock and we will be returning here at the top of the hour. And we are not using our speaker system because we haven't had any problems in everybody hearing, but if you do have any, please raise your hand and let us know when you can't hear us. We're recording today's presentation and they will be available hopefully within the week on the IPshowcase website. We'd like to introduce our crew. We have our skipper, Marta. Hi, welcome. Our hostess and first mate, Michelle, and she will be bringing around coffee and water if you would like coffee. I think some are already on the tables, but we'll be bringing some out as we go here. Please help yourself to snacks, and if you have any questions during the cruise, please let us know. And here we'll have two speakers, 20 minutes each, about 5 minutes for Q&A. And then when the boat starts to turn, that's our cue that the first speaker's time is up. So we'll get started. Go right ahead.
Okay. Good. Thanks for being here. Nice to meet you all. My presentation is a little bit maybe different from other IPshowcase presentations because most IPshowcase presentations tend to focus on specific technologies and very technology focused. And I'm an expert in the expert hub for 2110 networks at Quest Media. And I'm dealing with a lot of different projects because I basically get handed from all the 2110 projects, around all the 2110 projects. And if you see a lot of projects, you see that some of the projects go bad and some do better. And most of the time then you attribute it to like a specific vendor or a specific technology. This doesn't really work very well. But then I came across two projects that one was doing very well and one was doing not so good. And they used very similar technology stacks. And then I thought maybe there's something more to technology, like if a project, especially a 2110 project, goes well or not. And I thought it might be good to do a presentation about what else is there except for technology that makes a project go well or not so well. And last year I did a presentation on Blackburst and PTP, and I related it to the Beauty and the Beast, and I thought that was fun. And so this year I tried to come up with a different story around it, and I found the fairy tale Rumpelstiltskin, which is from the collection of the Grimm brothers. Originally it's in German, but I found a translation somewhere in the internet. I'm using that one to guide you along the things that can go wrong in a project. And the tale goes like this. Do I have something like a clicker or something? Okay. Thanks.
There's like 4 seconds of delay. Just be patient.
Okay. Okay. Good. Now, yeah. And it goes like this. There was once a miller who was poor, but he had one beautiful daughter. It happened one day that he came to speak with a king. And to give himself consequence, he told him that he had a daughter that could spin gold out of straw. The king said to the miller, "That is an art that pleases me well. If thy daughter is as clever as you say, bring her to my castle tomorrow so that I can put her to the proof." So what is this exchange? It reminded me of a sales cycle or a sales pitch. Yeah? And the interesting thing that first comes to mind is the miller's daughter. She's not part of the conversation. She's not even she has nothing to say in this, although she is the subject of the conversation. The other thing that is obvious, not now, but later when you read the full tale, the miller disappears. He's never mentioned again in the whole story. But that's only the most obvious things. If you look a little bit deeper, then you find that there is a difference in status between the miller and the king, obviously. I mean, the miller is poor, of low status, and the king is of high status. And because of that, the miller, he wants to build consequence. And for that, he tells what first seems like a blatant lie. the king, who is of high status, he accepts what is, for us, considering a blatant lie, literally. And the question is, why does he do this? Because it's pretty obvious, even, I mean, if you believe in things like magic, the miller probably has some access to straw somehow. Why is he poor if his daughter can spin straw out of gold? And gold out of straw. And that is a thing that's obvious, but probably it's only a misunderstanding, because if you take a very specific straw and put it through a very specific process, and then you can soften the fibers, and in the end you get linen. And linen you can sell them, and it gives extra income to the miller, and it seems to him like it's gold, because I mean, for a poor miller selling something extra, that's pretty much so. The first thing is in the sales phase, you build a solid foundation for your project, and you do that by first building trust, not consequence. If you're trying to impress people, then it's already bound for failure at some point, because in the end you will need to have to deliver on the process. But this goes both ways. Also, the customer should not be like the king, because you should aim for communication at eye level. Once someone told me, if the customer is the king, he will treat it like kings in all ages. He is courted where he recognizes it, and it's betrayed where he doesn't recognize it. So you better not be the king. Aim for communication at eye level, and trust. And then, if you notice something is wrong, like the king should have noted it, and we will later see that he didn't really believe the miller, but he did not call it out. He said, yeah, he will just give it a try, I have nothing to lose. But in your project, you have something to lose. Even if you have like a contract and they say, whoever I'm contracting, he needs to fix it, it will take time, it will cost money, it will just spoil the project. So if there's something wrong and you notice it, then call it out. The next is understand what you're getting. So we see here that there was a misunderstanding just about what it is. I mean, the miller meant something completely different probably than the king was expecting. And that's why all these IP presentations that go, IP showcase presentations about technology, why they're so important. Because you learn what you're getting, but also what different flavors of IP technology are there and how things can be done differently. You can do it with a monolithic spine in the network. You can do it with a spine leaf topology. You can do it with SDN and so on and so forth. There are many flavors, and it can easily happen that in the sales project, in the sales phase, you're talking different angles and you don't really come to the same conclusion, although you think you are. And that's something you need to keep an eye on. And if something seems not right to do, if something seems too good to be true, then it probably isn't. Either it's not too good or it's not true. And the second thing is, if you have concerns or something not understood, you have to voice it. You have to really make sure that both sides understand what it is about. It might seem obvious, but I've seen projects where it wasn't the case, and then in the end, that can spoil a project. But back to the story. When the girl was brought to the king, he led her into a room that was quite full of straw and gave her a wheel and a spindle and said, now set to work, and by early morning, if by early morning thou hast not spun this straw to gold, thou shalt die. And he shut the door himself and left her alone. And so the poor miller's daughter was left there sitting and could not think what to do for her life. She had no notion how to set to work to spin gold from straw, and her distress grew so great that she began to weep. Then all at once the door opened, and in came a little man who said, "Good evening, miller's daughter. Why are you crying?" "Oh," answered the girl, I have got to spin gold out of straw, and I don't understand the business." Then the little man said, "What will you give me if I spin it for you?" "My necklace," said the girl. The little man took the necklace, seated himself before the wheel, and whir, 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 3 times round, and the bobbin was full. Then he took up another, and whir, 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 3 times round, and that one was full. And so he went on till the morning, when all the straw had been spun and all the bobbins were full of gold. At sunrise came the king, and when he saw the gold, he was astonished and very much rejoiced, for he was very avaricious. So he was astonished. So he didn't think this was true, but he still threatened the life of the daughter and tried to make her do what he thought was impossible. And later he said, oh, it's possible? Very well. So that proves the point. You should voice your concerns, because otherwise, bad things happen as we will see. Then he leaves the daughter, goes out, closes the door, locks it, and leaves her alone. In your project, you should always stay engaged. I mean, maybe this worked for SDI project where everyone knew how they would be working, but in 2110 or in IP-based networks, it's all about flexibility. So there are many things, first, that you learn during a project, and then that you need to decide during a project. So stay engaged all the time. Projects that don't run well, most often the customer goes away and says, yeah, you're finished, and then we'll see us at acceptance, and then we accept the whole thing, and then it's fine. But it simply doesn't work that way. And in other projects, I've encountered customers that really want to do the thing themselves, because it's not only about seeing, but also about doing. And then sometimes people say, no, you don't, let me do it. Like the customer itself, although it's like our work to do, he said, we want to do it themselves because they want to learn to know how things are done and really do that themselves. And if we can help, I mean, we're always there. We can help, we can teach people, but if they do it themselves, then they learn so much more. So, and sometimes they say, no, we don't have time. Then we do it for themselves. That's also okay, but you need to stay in touch and engage. The next thing is, like, obviously we're not threatened with death in most projects, but sometimes if you set your stakes too high, then the pressure becomes so high that people find of ways like hiring somebody who comes just in to spin the straw of gold. Gold from straw. So first of all, things can go sideways with too much pressure, and the other thing, it hurts the trust that you're having. I mean, there's always some pressure in the project, which is totally fine, but if it becomes too much, then people don't trust each other, they cannot tell about mistakes, and that leads to bad things in the end. And then, I mean, it would have been enough to prove it just to have like a bunch of straw and see if she can spin it to gold. But it was a full room of straw which she needed to do, and that's also something. I mean, for spinning straw to gold, probably it doesn't make a big difference if you have just a little bit or a lot of it. It just takes more time. But for projects, it's quite different. If you have a big project where you have lots of things, then and you try to set up everything in the beginning and say that's how we build it. It will take a long time, and on the way you discover things and you want to change something. So it's better to start with a small scope and later and see how far we get, like more in an agile way, so that you then can learn things and then expand on the learnings that you had. And it also keeps the pressure low, it also keeps the stakes low. So we had, I mean, there's always those projects where you build a complete facility and then you try to fix everything for the tender phase, and yeah, then you have a long project, and during the timeline you need to change around things, and at the end you have a big acceptance, and that's not really how 2110 projects work best. I have another example of a customer who just set up the network, and you think, wow, what can you do with the network? And he just took in external 2110 streams from an external party that was supplying streams for a football match, and just sent them to a gateway, and then they came out and got to their traditional SDI infrastructure. And that's a very simple use case, but they put that really for a high profile football match. They used it, and they really did it, and all the operations people were involved, and that also means that during the trainings they were much more focused because they know next weekend there is this football match, and then the system is going. But it's easy. There's no switching. There's nothing. It's just pure transportation. It builds confidence. The system is going. We were on call during the whole football matches. I was a series of 6. We didn't get a single call because it was just an easy use case. But it built confidence. The people know the system. That people know that it works at least at this level, and then you can build up the next level, put control layers on top, and so on and so forth. But that I found a really good example of how you can start small and then build gradually up. And now the system is up to this level. We'll add a playout system or whatever have you, because the playout system will have its own problems, definitely, because playout systems always are complicated. There's a lot of workflows in there. And then if you know, we have seen the network and the infrastructure in production already, then that gives you a layer that where you say, okay, that's at least that's fine. But of course, you have to manage the complexity carefully, because you can also, if you start too early, start building things on top of each other, then it can get very complex. So, to the next part. I think if I read all this and we're running out of time, I'll skip a little bit ahead. In the following nights, the miller's daughter has to spin straw from 2 more rooms. So she has done the first task, and the king sees, oh, it's going very well, and now she has to 2 more rooms. With the 3rd room, the king doesn't threaten her life, but he promises to make her his queen, to marry her if she successfully completes the tasks. And again, the little man comes. For the 2nd room, he gets the daughter's ring, but that's everything she has. And with the 3rd room, he wants to get her, as she says, no, I have nothing more to give. He says, I want your first child when you become a queen, which seems kind of unethical, but he says, I want. She promises him all the riches of the kingdom because when she becomes queen, he says, no, I don't want any riches. I want something living. That's better than any riches. The straw is spun, the wedding is held, and I mean, if the king only would have stopped after the 1st room, everything would be fine. Everything would be happy. He would have gold, and nothing. No one would be hurt. I mean, the necklace, okay, but that would be fine. Yeah, but instead, the king extends the scope of the project, and that's what we call scope creep. Yeah, and that's also something to be aware of. First, consolidate what you have got. As I said, I mean, you first do one thing to the end, like doing an acceptance, and then you start building on top of that. And the next thing is, here we see what not having too much trust leads to, because, I mean, at some point, especially when her life is not threatened, the daughter could have come up with, I have made a mistake, there was something else, I didn't do it, and so on. But here also the stakes were too high. I mean, becoming a queen, well, the proposition of becoming a queen was too much of a pressure for her. It's another kind of pressure, it's not your life, but it's also, and that can also lead to things going sideways. And I don't want to say that everything needs to be very rigid. Rather, on the contrary, you need to be flexible. But and as I said before, start small and enlarge things later. But you need to build things first before you build on top of them. Build them to the end and really have them accepted and in production. And now the king. It's suddenly it's like before it was just something between the daughter and the little man, but now it's becoming more serious for the king, because I mean the queen the daughter is promising his child, so he is very affected now. Okay, and then what happens next? In a year's time, the daughter brought a fine child into the world and thought no more of the little man. But one day he suddenly came into the room and said, "Now give me what you promised me." The queen was terrified greatly and offered the little man all the riches of the kingdom if he would only leave the child. But the little man said, "No, I would rather have something living than all the treasures of the world." Then the queen began to lament and to weep, so the little man had pity upon her. "I will give you 3 days," said he, "and if at the end of that time you cannot tell my name, you must give up the child to me." Okay, what does the queen do? I mean, she obviously has a problem, and she tries to shift the problem to somebody else, like the little man. You shouldn't do that because, again, I mean, solve your problems later. I mean, it's okay in a project where you have a trustful relationship to give back and forth some things, but if it's a one-way thing like here, I mean, what does the little man get? He just is good willing to extend what they have been agreed to, and generally in projects, if it's a one-sided thing where somebody is offering goodwill gestures, it will not last very long. In the first night, the queen tries to come up with names on her own. In the second night, she sends out messages to inquire for names, but they are not the right names. The little man always answers, "No, that's not my name." The third day, the messenger came back again and said, "I have not been able to find one single new name. But as I passed through the woods, I came to a high hill, and near it was a little house, and before the house burned a fire, and around the fire danced a comical little man, and he hopped on one leg and cried, 'Today do I bake, tomorrow I brew. The day after that, the queen's child comes in. And oh, I am glad that nobody knew that the name I am called is Rumpelstiltskin.'" You cannot think how pleased the queen was to hear that name, and soon afterwards, when the little man walked in and said, "Now, Mrs. Queen, what is my name?" she said at first, "Are you called Jack?" "No," answered he. "Are you called Harry?" "No," answered he. And then she said, "Then perhaps your name is Rumpelstiltskin." "The devil told you that! The devil told you that!" cried the little man, and in his anger he stamped with his right foot so hard that he went into the ground above his knee. Then he seized his left foot with both hands in such a fury that he split in two, and there was an end of him. Now that's a drastic and sad ending. I mean, I knew that everyone would be over 18, so it's probably okay. I learned this ending very early as a kid, and it stuck in my mind. Later, I discovered that the Grimm brothers had two less drastic endings. The first one, from their handwriting, was that the little man flies out the window on a cooking spoon, and the second was he angrily runs into the woods and is never seen again. I mean, it really doesn't matter. He's gone, and he can't spin any straw to gold anymore. And yeah, that's also something to keep in mind. If you do things like I've told you in the presentation that are bad for the people, that are stressful, then they might not be there. And I've seen in late 2110 projects, I've seen quite a lot of churn where people are leaving companies or projects or whatever, and that's bad. I mean, it's bad for the project, it's bad for the company, whatever. It's never a single issue why somebody leaves a project or a company, but you have to keep that in mind. I've talked to a friend of mine who is an employment lawyer, and he said that the new metric for failed project is not how many money you lose, but how many people you lose, because I mean, we all see that people with very specific skills are in high demand, and you should not lose them. So if you treat those that actually do the work badly, then they will leave you. And that's also something to keep in mind when you think about how you conduct your projects. And it's not about the money. The little man could have had all the riches in the kingdom, but he said something living. Okay, now it's the child, and it seemed to be unethical, but it's a symbol for that it's not about the money, not about possessions. It's like about trust, about just being, I don't want to say kind, but just make a good work environment in your projects, because then the outcome will be good. And that's all for me.
We have time for 1 or 2 questions before we need to switch speakers. Do we have any questions?
How many people got lost in the bad project?
5. Okay.
All right, let's welcome, if you want to swap spots with
Yeah.
Stefan. And can you hand him your mic?
Welcome everyone. Thanks for being on board. I hope you're going to be on board with what I'm going to tell you right now as well. This is about minimal status reporting using NMOS. And I'm going to dive right into the topic about the history and the motivation behind all of this. I'm from a company called Simplexity, and we are working on behalf of Swiss Radio and Television, the Swiss public broadcaster. And they were one of the early ones doing full IP installation, and I was happy, or I'm still happy that I was involved in there. They're on air since 2020, and it's working. It's cool, you know, all great. But one of the issues we still have there is actually that a lot of operators are working mostly blindly if it comes to networking and the IP side. Thanks God it works, but you know, there is a second phase to that. So they wanted to do a second phase where the whole monitoring on packet, on stream, on network level comes in. So we started to discuss with with some of the key vendors what's possible on eye level, actually. So we consolidated that first phase, and then we started the next one, and we said what's possible, what creates a lot of effort for you, or what's doable, and all this kind of stuff. And it became pretty obvious that we need to reduce to the max. Basically, we can wish a lot of stuff, and there's obviously a lot of very sophisticated monitoring systems out there. But you know, we wanted to have a very practical solution, which is doable for the manufacturers as well. So what we did is actually we consolidated on 4 what we called alarms or statuses, and wrote a white paper about that. That was published. And we got a lot of positive reactions from other broadcasters. So then we went to AMVA and said, you know, why don't we standardize something using NMOS, so you don't have to write drivers for every and single device doing this. So AMVA was very welcoming that initiative, and now I'm very happy to introduce you to a specification called BCP08, which actually standardizes a minimal status reporting. A minimal status reporting. Doesn't do everything you can dream of, but it's doable. So the goals were of this whole thing was basically monitoring key elements and allow flexible setups. That means also, you know, go the step further, which we all want from IP, being flexible, maybe moving devices around without then manually do a lot of setup on that. So what we came up with is what we call a traffic light approach. We basically distinguish between 3 states and obviously also a non-active one, red, yellow, and green. And basically we always say, okay, is something healthy? Is it partially healthy or is it unhealthy? Specification is obvious. Healthy is whatever we are monitoring, a domain, a service, let's call it service for now, very generic thing for now, is healthy, it's working, and it's okay. There's no irregularities. Partially healthy is yellow, right? So the service is still okay. There's absolutely nothing wrong with what you get, but there is something you should probably look into. And the red, obviously, their service is not okay. So what we mean is actually we are targeting the end users. We are not targeting the experts who can already today dig into log files and stuff like that. We are targeting users on MCR level and whatever, and let them know and grow confidence about the IP side. So on a yellow state, they should probably do something in the next break. On red, they should probably call someone right now. So, on that traffic light approach, it did that before, so I'm just going to stay calm. And it's going to come up again.
There's a button under the board. There's like a mute button.
A mute button? Can you do that? Thank you. Which one?
That one.
Oh, wrong button. Like. Okay, so what's the point about this traffic light approach? First, we move some intelligence into the edge devices. We don't centralize everything because we believe some of the simple stuff is always the same and really should be decided by the edge devices already. So by doing that, we reduce the overall system complexity, setup work and all this kind of stuff, and we allow, in some cases at least, a straight mapping to user interfaces by doing that, without a lot of intelligence in between. Second point, which is quite fundamental to this approach, we work with active notifications, not polling. So we need a protocol, we needed a solution which is able to notify subscribers, let's say, and say, hey, here's a state change. So that obviously reduces traffic on the network, but also reduces monitoring load, whatever you have. So we want to go from small to big. We want to have a little $200 device in mind as well as the $20,000 devices. So we also said all the reporting should have a delay of 3 seconds as a default. We want it to be very practical. And that means before a device returns to a healthier state, so red to yellow or yellow to green, it has to have that state for at least whatever that delay is, which defaults to 3 seconds. So you shouldn't get flapping, all that stuff. So that's another kind of corner rule which we introduced there. The other one is we map the status to senders and receivers, because that's where the signal starts or arrives. That's what the operators kind of focus at the end. So we don't kind of make a distinction between device related and whatever. We map it all to the senders and to the receivers and say, hey, is it green, is it yellow, is it red? So some other corner elements to this. We do have -7 in mind. So, obviously, if you lose one network, the other one's still up and running, you only go to yellow. If you lose the one and only network you have, you go to red. That kind of stuff, right? We have a message field for optional information. So we want to keep this open as well for the manufacturers. They can always fill in that message field with a cause why it's in that state. But we don't tell them what they have to write in there. It's down to the manufacturer. But again, we expect some UIs to actually reflect that message to the users. There is a possibility to execute commands, some of them, like resetting counters and stuff like that. And the whole thing is actually open to fine-tuning those conditions. So the manufacturers can still decide, in my device, this is actually still yellow because we are able to still continue the service under whatever conditions. So that's actually quite open for that. It's also possible to extend with additional statuses. We only define the minimal statuses. Manufacturers can put in more if they want. And generally, we are not just focusing on 2110. We are actually also having older, even asynchronous technologies in mind. Now, let me introduce you to the, let's say, reporting domains. The 4 errors I was already mentioning, the minimum which we expect every manufacturer to do. The first domain is about connectivity. So we basically ask, is all the data arriving? And that has 2, let's say, sub-domains. One is actually packet level. Do you get all the packets in time? And the second one is, do you have a physical link? Obviously, the first one indicates already when you lose a link. But we introduced that physical link thing because we expect this to be very practical usable. That, for instance, in a dynamic setup, you know, hey, someone didn't connect that cable yet, right? Then the second one is synchronization. Do you have what you need? And the third one is actually, can you decode what you get in the packets? And finally, there's a fourth state, which is an overall state, which actually is the minimum for someone to look at, and it will always have the worst condition of the others, right? So if all of them are green, the overall status is green too. If one of them is yellow, it's going to go yellow. So again, with a message field which says which state it would be. So that's basically it. Now I'm going to just by example walk you through those 4 errors and the traffic light conditions, and it's pretty obvious. Basically, you know, on the connectivity on a packet level, green means I got all the packets in time. Yellow means I got some packets missing, but I can actually recover it, let's say from the second network or whatever. And yellow means I got, we got packet loss. Now the message says maybe the reason, but there's also counters. You know, the device should report how many it was, and you can reset those counters. So that's just one of the 4. On the link level, it actually gets even easier. There's no counters. It just says, I got all the links up, or some links are down. You notice we don't say 1 or 2 or 3 links. It's just some links, which I expect to be up, are down, yellow. So we try to be very generic. On the sync state, we actually say, do you have all the sync, the external sync you expect? And we would go, by the way, inactive if you are on internal sync. So in here, you could even expect blackburst or whatever. It's just, do you get the syncs you expect, yes or no? Or is some you expect not there? That would also apply on a -7 network to both networks. You expect on both networks to be PTP, and if one of them is missing, you go yellow. Interesting here is we have a counter of the number of times you changed from one sync source to another, including grandmasters. So you would be able to detect there was grandmaster changes, but you're still fine, but there was grandmaster changes, which obviously shouldn't happen in normal conditions. So we had that. And then finally we go to the stream validation. Basically this says, can you decode the streams? Are you able to do that? Or are you not? Basically, I would expect most people just go between red and green. But actually, there are some yellow conditions where you see, hey, I am able to decode that stream, but actually what I see, for instance, in the SDP file, doesn't match what I'm actually getting. That kind of, let's say, irregularities. So that's on the stream validation side. Now, the important thing is, the interesting one is actually the overall status. The overall status, as I said, always reports the worst conditions. And that's the minimal thing you can use. And actually, those colors could be reflected right back to the UI, say, you're green. By the way, it also says, we have some details which I'm not going to go into during the presentation, but when you make a connection, you actually go green first, and only after 3 seconds you start going worse if there is something. So we want to avoid all wrong indications during the moment when you start establishing streams and stuff. So we try to be very practical here. So basically, that's where you can go. That can all be right away reflected to the monitoring system, and if you have a monitoring system, if you talk to these guys, they also say, well, great, we don't have to set up all that logic again and again and again. So even if you have all that power in the monitoring system, it simplifies your setup work. And finally, if a vendor has more status to report, the overall status would still be derived from that, and they would basically indicate all okay things. So that's quite flexible, that overall status. So what's the technical prerequisites? Manufacturers doing BCP08 need to implement IS-12. I know it's not very common yet, but IS-12 in combination with MS-05, which is the model specification, they started to split those documents slightly, so they belong together. These two documents describe what I would say a modern Amber Plus, right? It's basically using REST API, WebSockets, and all this kind of stuff. It's a very generic approach. You can do many other things once you have implemented these two documents. And one application is BCP08. How do you report errors or statuses? So this is actually what the vendors need to do. And yes, that's probably the biggest work they need to do. Not so much reflecting the statuses, because we expect them to have them anyway internally somewhere. So let me just give you a quick check on practical applications or use cases which we could think of. You know, issues like dirty or aging SFPs, whatever, or you have sync problems, degraded PTP layers, whatever. The overall status is always the worst of all of these on the right-hand side. And you notice that sometimes it's yellow and red. Well, the point is, it depends whether you have a redundant network. Then you're going to go yellow, or otherwise you go red. So that's why I couldn't decide on whether you're going to see yellow or red here. But basically, if you go through all these, let's say, possible problem cases, you will find that you will always get notified about what you see. And then you call the experts and say, hey, there's something wrong with my network. So what's the benefit of BCP08? By the way, the 01 and 2 distinguishes between senders and receivers, so it's not relevant for today. Basically, we want to have a driverless monitoring of most important AV over IP statuses. It's in line with the whole NMOS plug and play, so on ISO4 registration server. It focuses on the users, so it allows to react. It doesn't give you all the problems or solutions already, but you know who to call, basically. And it gives the users a confidence. It sheds some lights into the networking, which maybe they don't today. It's kind of a black box, and they say, oh, don't know what's going on there. So it covers a wide range of systems, from small without any monitoring system to very big with monitoring systems. Then they get simplified. Basically, the minimal effort is basically, once you have done the IS-12 as a manufacturer, it should be pretty easy to do what we propose here. And the whole logic and the setup of your installation is simplified significantly. So the whole thing is open to expand. You can report more statuses if you want as you can use that to do more than that. But the minimum status report, BCP08, is what you should do as a vendor. So basically, as a summary here, BCP08 reduces to the max. It's basically only reports practical and essential stuff. You should not see full screens of stuff you quickly learn to ignore and then never watch. It's the obvious logic is moved to the edge devices, not to the central monitoring system. It allows simplification for monitoring systems for all kinds of sizes. It's based on NMOS 12, and so it makes sense to you to really implement that. And the current state of discussion, just that you know, we have basically publicly made the receiver specs. We are still working on the senders. It won't be much different, but you can actually go and check it out. And we are welcome basically feedback on this whole thing. There are documents on this, the general AMWA homepage, but also the current link here. You're welcome to scan it or whatever. You'll find it. And the white paper from SRF. So kind of caught up on time. Thank you.
We have time for about 2 questions.
Wow.
So yeah, we have to bring on some more food for the afternoon, so we're gonna need a few extra minutes.
I'd love everyone to speak IS-12, but Rossa preaching Katina, Lavo want everyone home, and what I get in the end is Ember Plus.
What's the question?
Who speaks IS-12?
I mean, basically, right now, that's exactly the point. Obviously, we need to standardize on something, and the others are not open specifications. And the point is, you know, ultimately, we can't rule the world, but it's a trial to at least not do it yet in another proprietary approach. But ultimately, it will be the end customers asking the manufacturers to do it in a certain way. And here is the one and only open publicly available specifications for it. I can't solve the problems of the industry, but it's a trial.
Yes, thank you. This is Stan from Net Inside. when we're doing this fault seeking, I got kind of a problem that I've been bouncing around with support people, that I have an RTP clock that is 900,000 microseconds wrong in time. And the device is clocked. You see in the PTP track count, you see the black burst output, and you see it on all these tools. And it's hard to explain all these support people. And these kind of tools are great, but it's still missing these kind of standardized. I do the VAN side of connecting all these Arista, all these spine leaves around the world in one unified 2110 network. And there's one NMOS controller here, there's one NMOS controller there, and so on, in a worldwide network that I'm doing. So for me, it's that support tools that's coming more in that as part of you talking about is very important, but we have to evolve it much more. And for me, it's a question. The support call they pay for us, and then you have to have an Ordinate or a Love or whatever it is. All these support organizations have to talk to each other. It ain't just have a way to get an alarm. For me, this is because most of you go in your small LAN network, but I'm doing the VAN sign and connecting all these in 110 networks.
There's always room for improvement, for more. But I just quote Hartmut, just consolidate a good first step. And we try to make a first step, you know, improving what we, from an operational point of view, consider the most important thing. So it's achievable, it's practical, it's realistic. Yes. And then we can go further than that. Absolutely,
yeah,
there's lots of stuff we need to go further.
There's REST API and things like that. Yeah. Thank you.
You're welcome. So, whenever you have a chance, go to the manufacturers, ask for this. I know a lot of broadcasters already do, but it actually, for them, there's no business case unless you ask for it as an end user. So, just go and ask.
Yes.
So, if you are only having IS-12...
Maybe you want to hold the mic just for the
recording. Can you hear me?
Right?
Okay. So if you're having your IS-12 in the receiver side only, but not in the sender, will the traffic light system work? Or it has to be implemented in both sides, meaning that it has to be standardized across all the devices in the network in order to have a result?
So the answer is no, it doesn't have to be everywhere.
Okay. Basically,
you publish as a device, you publish in the ISO4 your ability to talk IS-12 and whatever, and then if a UI wants to use that, they basically via IS-12 ask for the statuses there are. So if they're only on the receiver side, it would just show and no, there's only the receivers and maybe only a few of them, I don't know. But it's basically, you know, you can ask through IS-12 mechanisms what's there, and then you can map those. So that's why it's called BCP now, 08. It's because there's no change to protocols. BCP 08 is the cooking recipe, how you have to basically use that data and what it should and when it should indicate what. And again, I'm not telling you we've solved all the monitoring problems of the world. I'm not telling you that. But maybe a big portion of it. There's one more question on that side.
Actually, we're out of time. I'm going to have to ask everybody to leave the boat. We just don't have any more time, or we're going to run late for the rest of the day.
Just a quick question, maybe.
Okay, go ahead.
Thanks everybody for having me. We're going to talk about Eurovision Song Contest from this year, 2024. This was the first ever 100 gig usage of 2110 in a live event. So it was a pretty massive undertaking to coordinate and brought a lot of new technologies. And hopefully you find it very interesting as we go through some of the details. So a little bit about me. I started Megapixel with my co-founder Keith in 2017. We've been innovating in the LED and processing space since about 2002. Previously, I started Element Labs and then Revolution Display. And we brought Helios to market in 2019. And it's the same platform that we've had since 2019. So this deployment of 2110 at 100 gig was actually able to leverage equipment made all the way back then, and we just simply upgraded the input cards. We do a lot of visual technology besides just LED processing as well, to kind of give an idea of kind of the breadth that we cover. I need to update this. We actually are now over 300 patents in both processing and display technology. We've won installation awards. We just won another Emmy this year, so we're up to 3. And we've got 3 Oscars for visual effects. So a lot of visual technology. We love lighting up pixels and capturing pixels and moving them around. So specific to Eurovision, I want to give just a couple key facts so that you can understand sort of the breadth of the actual project itself, because it's quite a large undertaking that Eurovision does. So first off, planning starts 2 weeks after the previous year. So that means that we're already working on 2025. So this is a lot of preparation that goes into this. The technical suppliers, we were a technical supplier direct to Eurovision, get onboarded very early, and always with the goal of developing new features and new technology that specifically gets deployed for the show itself. And a lot of this is to make sure that the direct support is there, because as manufacturers, we can support the equipment pretty much better than anybody else on the planet. This was the first time that since Russia in 2009, which is a long time ago, that a single supplier was responsible for basically all aspects of the technology. So that's lighting, sound, video, and broadcast equipment. So that was NEP Group. And that was a very big key factor, that they have such a global presence and own a lot of subsidiaries to be able to do that. So a little bit of backstory in terms of our involvement with Eurovision. We've been involved in the show since 2021. Production has a strong history of deploying new technology. So for this year, we wanted to deploy everything across SMPTE 2110. We were onboarded as the official supplier, and we worked very closely with CT, who is deploying all the visual systems for the production. And they've been using more and more LED now, just because of EU mandates for lower power and that sort of thing. So LED specifically has been used solely since 2022, so no conventional lighting fixtures, etc. There were a lot of pain points getting into this project that we started discussing early on, which is why we had moved towards 2110 as a solution. I don't want to get in the way of caffeine. So we have to move around tons of video data. We have complete redundant systems to make sure that this is going to be very resilient on air. There's very little time to troubleshoot when we're on site, because all of these changeovers happen very rapidly, and there's not really time at all. We need everything to be able to execute with perfection right away. And then we add in all of the complexity of baseband and routing and latency and all these things. It was very clear to us that 2110 would be the right solution. And a lot of times we're at the mercy of other products and network switching and media servers and all these things. So we had to really work together to ensure a lot of interop. So it was not only us doing processing, but it was media servers and everything upstream and downstream of us that we had to coordinate with. So this is an image of the stage, a little bit close up. There were LED cubes that were built, transparent, moved up and down. So a lot of different rasters were being controlled. This is a nice view from the audience. You can see the scale of this stage. There was a large element here too, which was the actual LED floor. This was used. I've got another photo in here coming up later. This was used not only for the live performance, but also for the quick change set piece changes. So the floor was actually used to basically put a blueprint together so that people would know where the set pieces went. This is an example of how let's say the spectacular view of the stage can be quite different in terms of, let's say, who's intended to see that particular portion of the stage. This is obviously a very small cube of creative LED. This is something that was really for home viewers because this is over broadcast. This wasn't necessarily so meaningful for people that were in the audience because it was a tiny little thing. But as an example, this entire changeover, you can see people like physically pushing the scenic pieces. This was a 45-second changeover to be able to make that happen. So this drew a lot of expertise both from our team as well as CT for having done things like Super Bowl halftime shows and those kinds of things that are just very, very rapid turnover. This is a nice image showing front of house. So despite the fact that 2110 really simplified a lot of the system itself, you can see the amount of control that's there. There are a lot of people operating all of these things to be cohesive. It's literally an army of people. So this is what I was referring to before, this practical LED floor. So there are little mappings here where all of the tiles got specific letter and number codes, and then you can it's a little hard to see with the glare, but they're color coded, so you can see that the scenic piece is coming in over the red lettering as opposed to the blue lettering. So this let people know where things physically needed to go. So I'll just let that play. There's a TV overlay. Yeah. There we go. Thanks. I'll play that one more time, maybe, so that it you can see that. Yeah. So basically, every country that came in, there were individual scenic pieces, and everybody was able to make sure that everything was aligned properly. So that's one of the biggest things. Is I think the artist changeover was actually one of the more technically challenging things that 2110 was really suitable for, because it allowed a lot of merging of data. So because everything was on one network, there wasn't SDI patching, there wasn't lighting patching. We were able to just very easily control what signals went where. On the video side, of course, NMOS was really key. So here's another example of a changeover. You can see all the lighting got refocused. They're testing that now. Again, you can see the markings in the floor. And now they're ready to go. So it's really, really fast. So this is the general network plan when we kind of take a bird's eye view of how the system was set up. We had the large front of house with all of the operators. There were two racks front of house. There was a red and a blue network. These were all very high bandwidth signals going backstage. to what we called video world. So again, there was a red network and a blue network. These were 100 gig fiber switch connections. Basically, so we had 400 gigs of fiber data going from front of house to back of house. And then once we go into a core switch, we were then able to fan out to all of the processing as well. All of the processing ingested 100 gig fiber natively. And then I think I have another diagram I'll explain a little more. Yep. So this is just a different view of what we were looking at before. So we had 200 gig, 100 gig, and 25 gig connections. There was, of course, the 2110 gateway. There were 8 media servers on the red and blue network. These all crossed each other so that both Arista switches were able to get primary and backup signals. And these were all 100 gig core switches. In terms of our LED processing, we used 14 LED processors. There were a couple spares of each, so there were 10 active processors. So that's only 10 RU of equipment to drive the entire array. Each one of these connections was 100 gig fiber, so those are going direct into Helios. And we were able to, Helios was all NMOS controlled as well, so that anything that needed to go to a failover, if that was the case, or if there was a media server output that needed to get changed, all of that was NMOS routable. And then on top of the Helios network, so let me actually back up one here. So this is 100 gig coming in, so each of the processors had a 100 gig fiber connection. On the output of the processor, we then go to the thousands of LED tiles. And one of the things that is very unique and special about how Helios works is that it's also network compliant. This is something that we kind of predicted about 15 years ago and started building our tiles with MAC addresses, and they're essentially, all the tiles are kind of like IoT devices that are living on the network. So a very simplified view of the primary and backup system for Helios looks like this. So we have, imagine you've got the 100 gig input coming into primary, we have 100 gig input coming into the backup, and just like there's a red and blue network on the 2110 side, we also have a redundant network on the tile side. So the output of the processor takes the 100 gig. We have a lot of functionality in the processor in terms of color control and tone mapping and streaming ACN to be able to merge lighting data and video data, all those kind of things. Map the tiles, of course. But then on top of that, we downscale the bandwidth a little bit. We don't need a 100 gig connection going into a tile because that's very complex and expensive. So we go down to 10 gigs. We have multiple 10 gig outputs. The 10 gig output goes into another Ethernet switch. The Ethernet switch that's ingesting 10 gig or 20 actually today, so 10 or 20. This then lives very close to the LED wall so that your long haul run from the processing rack to the LED tiles is fiber. And then we have either 1 or 2.5 gig copper connections that go to the tiles. What's really interesting about the way that we've built out the tile network is that we have a redundancy system in the tile that we call seamless mode, which we were running in this project. The tiles are actually ingesting primary and backup, not for really like a main and backup, but actually simultaneously. So every single tile is ingesting 2 video feeds at the same time, and we do a CRC packet check on every single Ethernet packet. And so if whatever we have designated as the primary processing system failed a CRC check, the tile itself will actually insert that same packet from the backup system in place. It's really cool. You can literally go backstage and like start cutting fiber cables and copper cables, and visually you cannot see anything. It's completely glitchless. And this doesn't add any kind of redundancy to the system either. In terms of future, we're also thinking about this in terms of N+1 redundancy, like you would do IT networks. And so we've built some tiles that actually have 4 ports on them, so you can do up, down, left, right, and have tiles ingest even more than the main and the backup. So this is what the equipment racks look like. This is all the Helios. The equipment racks were actually so dense compared to the previous year that this was like right behind the cafeteria essentially. So there was catering and then all of the video land was there, and this was running the entire show. So there were 10 Disguise servers, 3 Arista switches, 14 of the Helios, 4 of which were just cold spares, 45 downstream 10 gig network switches. We had 2 Omnis monitoring appliances. That's an analytics system that we build on top of all of the LED processing that I'm happy to talk about separately. But basically, because everything is on an IT network, we're able to monitor and manage a lot of things. So you get a really nice single pane of glass view of aggregated, like all 10,000 of your tiles, and they're all beautifully color-coded and let you know where data's routing. And so overall, it was a 1.4 terabit network driving all of that, so reasonably complex. Because of all of the APIs that we have in Helios and the fact that it's essentially a big network that just happens to be running video, CT put together a really amazing monitoring dashboard. So they were able to pick and choose things that they wanted to see in terms of active versus backup status, how loaded ports were, what the network traffic looked like. They then had a more detailed network bandwidth dashboard to make sure that they weren't overloading links. So they were able to see core switch bandwidth, total bandwidth of the system, and then any kind of, they had a throughput test as well that let them see if they had any packet drops or anything like that. So this is really key because leveraging the networking infrastructure, you know, in the past with LED, it's been very difficult to troubleshoot because, you know, you'd see like a tile blink out of the corner of your eye and you say, well, what, I think I saw something over there, right? And it's driven by a lot of different processors. There's a lot of different systems involved. These types of analytics let you drill down and know exactly, oh, we had a data error between tiles 13 and 14. Let's go check the cable. So you know exactly where to look and when to look. Media servers, they were monitoring as well. And again, all being network-based, they were able to look at temperatures and traffic and all those kinds of things. So one of the things we really enjoy working with 2110 and IPMX because it's networked. So if we look at a traditional data path, if we were using SDI or HDMI, you know, we have footage that could be on a media server or some kind of network attached storage, could be in the cloud. We have a server, we have a router, we have the LED processor, et cetera. And all of these are serial connections. And so any one of these data points basically can be a failure, but not only a failure of the literal video traffic, but also of the metadata. So we can lose color information, we can lose frame rate information and other sidecar data that might be going along with the video. And with 2110, basically everything's connected to a switch, so everything can talk to everything else. And we also don't have that potential of breaking the chain, both for the video data, lighting data, comms, metadata, all those kinds of things. This I wanted to show. This is way too small to really get into the nuts and bolts, but this is these are the network topology diagrams for the red network and the blue network for the entire system that I've been just showing. This is so simple. Like if we were doing this the previous year and it was all on a combination of HDMI and SDI, this would have been 25 pages plus of documentation, and it fits on one. So again, really, really simplified. So Helios, as I mentioned, we were using the 100 gig input. We've pre-tested with a lot of different types of upstream data. We work very closely with Epic Games for Unreal, where you're able to actually take video texture from the GPU and go direct into Helios, which removes a lot of latency, which is pretty cool. 2110 and IPMX in general are reducing latency. We have less interconnects, of course, and I've talked a lot about the metadata. Again, simplicity, so this shows us the tile diagram in our interface. And because we have all the metadata information, we know what kind of colorimetry and chromaticity we're getting on the input, frame rates, and then we're able to automatically output the correct thing to the tiles and then send the right data to the tiles so that everything looks correct. And just one call out, you know, a lot of people are thinking about 2110 and IPMX from a standpoint of video, but this can be used for everything. So think about lighting and projection and pyrotechnics and, you know, audio, comms, camera tracking, all these things. These can all talk to each other, which is going to make all of the systems more and more simple over time. So I just want to give one, I think this is maybe the last one. I've got an example of camera cutting. This is something that could not be done by a human. That was really cool to see on Eurovision. So the camera cuts, the video source switching into the processing, and pyro was all controlled by NMOS so that it was all on cue. And if we watch, let's see, maybe one more click. Watch these cuts in the pyro. Am I out of time? Okay. So all of these cuts that were happening with pyro and the camera cut at the same time could not have been repeatable by a person. But the fact that a computer was able to control all of it together on the network, it is a first. And that's my spiel on 2110. Yeah, I tried to get it right. Yeah.
Does anybody have? Oh, is this on? Okay.
Did you need a microphone?
Yeah.
Do you want
Does
this
anybody
one?
have any questions?
I'll give you this one.
Go ahead.
What was the overall control system? Was there one single unit, like
There was, yeah, there was. Oh, maybe I'll hold it back. There was one single control system that was put together by CT.
Right.
So NEP Group has kind of its own internal, like, mega scale NMOS controller that they use for a lot of broadcast and live events.
Yeah. 2110 using for everything, for everywhere, in video, in pyro, in lighting. 2110.
All of it, yeah. Yeah.
So not the mix, for example, for lighting, but 2110.
Oh no, the lighting was a mixture. So the lighting was still was mostly streaming ACN. So it was on the network, but it was still like a sideband protocol. But the overall control was NMOS.
Okay.
Yeah.
Oh, does anybody else have any questions? Okay. All right. Thank you. All right, Andreas, you ready?
Yeah, thanks, Jeremy. I watched that TV show and it was just great. So I had lots of fun watching all these amazing effects. And now I unfortunately have nothing comparable to tell and to talk about. It's more the dry stuff. It's about audio, mainly about the audio AS67 and IPMX and how these things finally come together. Just a quick overview. I'll give a very quick and brief overview of AS67, 702110 and NMOS. Quick introduction, because you've all have heard this about IPMX, and then the more important parts, the timing models of IPMX, and how what that does mean for the interoperability between IPMX and AS67 and 2110. Again, my focus is on audio, but most of this can also be translated into the video side of things, of course. So, AS67, what was the original goal of AS67? Well, we had a number of disparate audio over IP systems which cannot talk to each other. And the idea was, can we achieve interoperability between them on the basis of IP? So they are all based on IP, these solutions like QLAN, Livewire, Ravenna, Dante, Weetnet. There are probably a few more out there. They cannot talk to each other except, you know, running audio lines. So except Livewire and Ravenna did work out in 2012 already how to talk to each other. But the idea was, if we define something which we now know is called AS67, which is supported by all of these different solutions, then we can exchange audio directly on the IP layer. So what is AS67? It's an interoperability standard. It's not a new standard, yet another standard. It's an interoperability standard, which is using existing protocols based on trusted IT standards, and that is designed to run on existing networks. So finally in 2013, right at IBC, so that is 11 years ago, AES67 saw the light of the day, and just as in order to quickly understand what we are talking about later on is every standard, every definition has functional blocks like synchronization, media, clock transport, and so on. And AES67 defined a mandatory minimal functional set or protocol set for each of these blocks to finally assemble something like AES67. So all the IP solutions needed to support these minimum functional requirements in order to achieve interoperability among solutions like Dante and Ravenna. And what we deliberately left off was discovery, because there were already existing schemes out there and we could envision that other standards would come up, and so we didn't want to force any discovery scheme with the AES67 interoperability. Focus for the interoperability with what I'm talking about later with the IPMX is, of course, again, the synchronization and the media clocking, and parts of the discovery also coming into game when we talk IPMX. So if you want to learn more about AES67 here, just talk to me after the boat tour or just look it up yourself on the AES67 standards page that I see. So SMPTE 2110. Very quickly, it's basically very similar to AES67, except that it adds video to the game and metadata in terms of the ancillary metadata and everything. So basically, it's the same stuff AES has done for audio. If you look on at the IP side of distribution based on IP for video, we had the 2022 standard already in place, but 2022 is basically the full complex SDI signal encapsulated in IP, and that is being distributed onto networks. That is not very usable for production work because everything is encapsulated. If an audio console just needs to access audio, well, it had to unpack the whole SDI, the whole 2022 packet, and then just extract the audio. It's this de-embedding thing, right? So, and that's why we have this an essence-based approach of 2110, where we have audio, video, and metadata and whatever we need as individual essence streams on the network. And that is the ideal approach for production environments, and everything basically is held together synchronization-wise through PTP. We'll come to that in a second. This is just a picture highlighting the differences between the existing 2022-6 standard at that time. We have a complete SDI signal where everything is in one stream, in one flow, so every packet contains audio. Well, not every packet, but every essence number of packets actually for video, but they are all contained in the very same flow. And if an audio console only wants to work with audio, it has to receive the whole IP signal, de-embed the audio, re-embed it into a video and everything. And in contrast, 2110, we have these individual essence flows on the network, and the audio console only needs to register to the audio stream, to the audio flow, process the audio flow, and put a new audio flow onto the network. That's the basic difference between the already existing 2022 and the then released, and then with then I mean 2017. That's the year when 10 had been released by SMPTE. So just as a quick overview, there are lots of different standard documents describing different things like system timing, all kinds of video-related stuff. We have two important standards based related to audio, PCM audio and AS3 audio transport. Just recently, we released the -41 standard, which is the fast metadata exchange standard. And I just can encourage anyone who is, interested in the metadata thing, just come visit us at the Ravenna booth, because Dolby, Jünger, and Bridge Technologies are showing a real use case, which has been used already at the Olympic Games this year for metadata transport, SADM metadata transport based on -41 as a real use case. And we have that up and running at the Ravenna booth for demonstration. But now we are turning to the audio side of things and the system timing, in particular to the linear audio, which is defined in -30. So what does -30 specify? Basically, how uncompressed linear audio, PCM audio, is being transported and essentially we can say it's just the same as AES67. It adds a few little things here and there, but basically the two schemes are mostly compatible. One exception is that 2110-30 defines further conformance levels. AES67 only talks about 1 millisecond packet time, and that is conformance level A, versus B and C go down to 125 microseconds. That's an option for AES67. It's also option for 2110, but they are clearly defined if you want to have shorter packet time. So that's basically what we're talking about, and that is also becoming important for IPMX now. If you want to learn more about 2110, again, just talk to me or turn to the 2110 FAQ webpage or download the standards to read them by yourself. Well, usually those fully working systems cannot be built on just 2110 or AES67 alone, so we need more for a network system. Discovering resources, establishing connection, sort of these things are partly covered by Ravenna, Danta, Livewire, and others. They are not covered by AES67 2110, as I highlighted earlier. Discovery was not part of the definition. So other things need to come into game, and that's, Jeremy already mentioned that. That's the NMOS suite of specifications or specification documents hosted or driven by AMBA, the Advanced Media Workflow Association. And so NMOS is designed to accompany any AES67 or 2110 transport or media infrastructure themed to provide discovery, connection management, control, and other things, and it's becoming a very important factor in the IPMX kind of thing. So just an easy diagram: we have all the transport layer stuff, which is covered by AES67 2110, and then NMOS adds things like discovery, registration, connection management, audio channel shuffling, and there's much more. Which is being worked on within NMOS or has already been defined, and it's very useful and important for this. So what is IPMX then? IPMX is an initiative by AIMS, and it's called the IP Media Experience.
IP Media Experience.
IP Media Experience, right? And basically, again, like the whole AIMS initiative, for the other IP standards, it defines a common set of standards-based protocols which foster the interoperability for the pro AV industry. Now, 2110, AES67 have all been designed with the ideas of mostly the broadcast side of things in mind, and now IPMX is targeting the pro AV, the commercial audio, signage, everything you have seen, in the Eurovision, for example. Besides audio, it also incorporates other things like compressed audio video stuff, various video formats, HDC copy protection is an important part of the game, and of course discovery, registration, I/O stuff. And also they were looking at enhanced or relaxed timing, because the strict timing requirements set forth in 2110 for the broadcast use cases may not be required in most of the pro AV use cases. So the goal of IPMX basically is simple deployment on networks, on IP deployment on networks for the pro AV use cases. IPMX started with the existing standards, 2110, NMOS, but more functionality was needed. Essentials of what you have these days at HDMI, and all these existing and new ingredients together build the IPMX suite of standards, basically. That's the idea of IPMX. IPMX itself, the technical parts, are mostly driven by the Video Services Forum. They are producing the VSF technical recommendations, and the whole suite of TR10, again, you can see lots of documents here, is basically defining the IPMX standard. And other things are driven inside NMOS working groups, so particularly the edit data information, HTTP stuff, and more is all being covered by various NMOS groups and NMOS documents. Some of them are available, most of them are still in the works, are being worked on at the moment. All this together comes into IPMX, and just a very, very brief view, don't want to bore you with technical details at this particular point. That's the infrastructure and the physical layer. Then we have the existing standards like 2110, AS67. We have the various TR10 definitions which run on the technical infrastructure. We need additional functionalities, USB, GPI, and so on. Everything what is needed, typically needed in Pro AV use cases. Things which come with NMOS, and NMOS also will stretch out into covering some sorts of these GPIO, not GPIO, these control and IO stuff things. And then on top is a layer where you have what we call this application layer, but there's where we have control, we have authorization, access, and all these kind of things. And then all this is, just sort of a high-level view of what IPMX basically can seen as being built off. Now, we come to the important part of what I was talking about the clocking and synchronization, because that is what is really important, especially when you look at the audio side of things. IPMX defines basically 3 different operating modes. I call them operating modes. We could call them streaming modes. It's exchangeable basically at this point in time. First of all, because IPMX is based on AS67 and 2110, it incorporates what we call the fully synchronous operation. That is what is defined by AS67 and 2110, where all streams on the network are working on the very same common reference clock, and so they are working in fully synchronized way. That's basically what AS67 and 2110 about, and IPMX thrives to be based on this, so that's one of the modes IPMX needs to support. Then we have an asynchronous operation mode. Well, most of the Pro AV use cases do not need the full synchronous operation. In most cases, it's fully sufficient if you have a signal which is running on its own media clock, you throw it into the network, it's being received by a receiver somewhere, and it doesn't matter if it's really synchronous, sample accurately synchronous to anything, like an HDMI input signal, you throw it onto the network, you play it out on a TV screen somewhere, cinema, foyer, or something like that, right? However, there's in this mode, there still is a common reference clock available, so you can relate the asynchronous input data time-wise to a common reference clock, to time, so that the receiver has the chance to play out any input signal at a certain given time. Right, so you have a time-wise relationship. We'll come to that in a second when we have the diagrams. And then there's the most often fully asynchronous use case where you just, put the example, you just insert an HDMI sender signal onto the network. You want to receive it some 100 meters away and put it out on on another screen in the next room or foyer or whatever. And you don't need any synchronization to any sort of signal at all, right? So that's these 3 use cases: fully synchronous, asynchronous but with a common reference clock, and the full asynchronous case where you don't have any media clock relationship. Let's state that IPMX at the moment defines all of these three operating modes as mandatory. So all the IPMX devices have to support these devices as it is right now defined by the standards. I know, I see your things, but you can add, you're ready to add some words at the end. Important is, these 2 modes require a common reference clock on the network. That translates into PTP being available on the network. The 3rd mode is the one where you don't require PTP, because, well, there is no common reference, it's all asynchronous, no PTP is needed on the network. What's the PTP stuff of thing? PTP is the precision time protocol. It's an old standing protocol, basically, originally released in 2002, revised in 2008, and it is yet another revision in 2000, give me help, 22, 21, something like that. We are talking, when we talk PTP, about the 2008 revision, the PTP version 2 revision here. You can have a GPS reference or not, depending on the use case. It's a proven technology, not only used by us in the professional media world. It's measurement, military, instrumentation, whatever. So it's a really widely used protocol. It's not just invented or used for broadcast applications. And it's basically there to distribute time, to precisely distribute time to devices. It's not the media clock which is distributed, it's time. So we synchronize clocks with it. And it's important, both AS67 and 2110 are fully based on PTP as the common transport protocol for the common reference clock. Let's have a quick look at the first one, the fully synchronous operation. Well, basically that is identical to what AES67 defines. Let's have the case with the analog audio. The analog audio is coming into an A to D stage. The digital data gets packetized, and then a packet is sent out to the network. With AES67, the mandatory packet time is 1 millisecond, so we have 48 samples if we are doing 48 kilohertz in one packet, and it's shooting out to the network. Now, the A to D converter needs to be driven by a media clock, right? So that media clock, in turn, is driven or derived from a local clock, from a real time clock. So if you have time, you can translate that into a media clock. If you have time, you can derive any media clock you like, let's say 48 kilohertz, that drives the AD converter. And that internal clock, in turn, is being synchronized via PTP from a common reference clock. That is the full synchronous use case for analog audio. If we move over to digital audio, it doesn't change much, except that the input source, the digital input source, is synchronized to that media clock. So either by a gen log or by a word clock signal or whatever, the external digital input device is synchronized, just as you know from the traditional traditional digital use case, right? You have lots of studio equipment, you're running a house clock around, that's the synchronization mechanism. And the devices have to follow that reference, what is output right here. So that's the full AES67 way of setup. And if you need to synchronize multiple devices to the very same time, you have a master clock in the system, is GPS referenced or not. PTP is distributed to the different devices, to the different clocks in the devices. And from there, we generate independently the media clock locally on every device. But since we have absolutely the same precise time, we have the same in-phase media clock running at all devices. That's the way how the media clock generation and distribution, which actually isn't a distribution, works. Then another important factor of the AES67 stuff is that we have a deterministic playout. Because we have time in the system, we can now tell every device when to play out particular samples, so that both speakers, or let's say an example like the Sphere in Las Vegas, which has 1,600 of these speakers, that they don't play out whenever they arrive a sample, but they play out at the very same sample aligned time. Otherwise, these systems just won't work. And that is managed through the link offset. Very quick and easy example, and thanks, Andrew, I stole that from your presentations. We have a sender which is generating packets at a quite isochronous way and emitting it to the network. All these packets have the origination timestamps with them, and our receiver, depending on where it sits on the network, might receive the packets at different times. And now it's the goal of a management system to align to the maximum required time to establish, to calculate the required link offset. And then by telling the receivers, okay, you all have to play incoming samples with this particular link offset with respect to the origination time, we have a perfect sample accurate alignment of the playout of all these streams. That's basically how every ST2110 and AES67 based infrastructure is working. The benefits, of course, all media clocks follow a common reference clock, and we have accurate reproduction of the reference clock at all local modes, and identical or phase accurate, even phase accurate media clocks for all streams. We can concurrently process any incoming stream because they are all following the same media clock and they all have the time information. We have deterministic latency because the time information and any desired alignment is possible. We can even build, delay lines if we have live equipment and have front hanging bananas and the next one in the audience further back. We can build these delay lines for, no money at all. Basically, well, buffer inside the receiving devices, but it's not as expensive as dedicated devices here. The big drawback is we can't process and transport asynchronous signals. So all devices which participate in this network need to be synchronized to the common reference clock. Any asynchronous input signal needs to be sample rate converted before it actually is in line with all the other signals. So not just like, I have an HDM input, I can transport it with AES67 just over and receive it somewhere. I don't care about synchronization, not working. PTP is required, and some people consider, well, if PTP is required, we need a more complex setup then. Maybe true, it's sure more complex than without PTP, but what is complex? Anyway, that's certainly an aspect. Now let's look at the asynchronous operation mode where we have a common reference clock available. Again, we have the same picture here, and what we are omitting is the link between the clock and the media clock. So that means the media clock can either be free running, right, or could follow an externally provided clock. And with that media clock, the analog signal is digitized and packetized. Now, since we have a reference time, because we have PTP on the network, what we can do is we can provide information to anybody who wants to receive the streams when any particular sample has been gathered. Because we have a reference time, we have a media clock, which is running, and we can at every, well, we won't do it at every clock cycle, but we can exactly measure, okay, what was the time when this sample has been gathered, what's the time when the next sample has been gathered, and so on. So we have a relationship between a common time known to everyone on the network and an individual free running or whatever media clock. So the receiver finally can resample the unknown media clock from the incoming information about what was the common reference clock time that particular period has been acquired, and what's the next one, and then I can reassemble the media clock. It can perfectly align the media clock from the input side. And that is done through the RTCP stream of packets. So in theory, it's not for every media clock cycle, but in theory, every media clock cycle has a timestamp. When was this clock cycle started? On the digital side of things, it looks different. We don't have that link anymore. But for the digital signal, that is now driving the media clock because it's already there. It's already digital. We packetize, and still we build these RTCP combination. Media clock was at that particular reference time. So it's a very precise way of resample that media clock on the receiver side of things. Main benefits and drawbacks of this kind of operations scheme: we have any individual input clocking, so we are not forced to be synchronized to the whole network anymore. We have a deterministic latency because now we know it's been gathered at that particular point in time, and we want to play it out after 2 milliseconds or 5 milliseconds or whatever. That can be achieved. We can precisely resample the digital input clock, really, too. Wow, it's 10 minutes left. All right, and that is the fact. But what we can't do is in a concurrent processing of individual streams because they still follow their individual media clocks. We know when they have been gathered, but we can't process any two individual media clocks because usually we only have one media clock running per device, right? But we have the benefit of supporting asynchronous signals. This is exactly the scheme AVB, by the way, works. So AVB is exactly using this scheme of operation. Now, third case is fully asynchronous operation without a common reference clock. So what we lose is the reference. We still may have a local clock running, or we should basically, but now there is a more or less useless combination of the internal local clock and the media clock because the meaning of the local clock is not understood by the other devices on the network. We can do some tricky stuff with this, but in principle, that local clock does not have a relationship to any other local clock on the network anymore. So we still have the RTCP reports. If they can be made use of or not depends on certain circumstances. And for the digital side of things, it's pretty much the same. We have this digital signal feeding the media clock. We have the RTCP reports, and stuff is going out. Benefits, of course, I can now use any input signal. I don't need PTP on the network. Drawback, of course, I have always individual media series with individual media clocks. I can't do concurrent processing in one single device. And also, since I don't have any relationship to time anymore, I don't have any deterministic playout. I cannot work with any, I want to have that or this particular link offset anymore because the time of the sender and the time of the receiver are different. But it's a very, very easy system setup because it's no PTP required there, right? Just input, output, done. So final question then is, I'll skip over this because that's the three operation modes which are resembled here. The PTP synchronous operation, PTP asynchronous operation, the generic operation when there's no PTP. We have a fourth case which is not defined by IPMX, but that's when I feed an external house clock around and synchronize systems again, but I don't have that done via PTP. But it's not defined by IPX. Now the final question really is, how do IS67 and IPMX work together? Can they work together? What are the constraints and limitations? General issues we see, IS67 always requires PTP. If there's no PTP, IS67 cannot work. IS67 devices don't support any asynchronous operation. So we always have to, for the interoperability, have to look at synchronous operation. Now, if you look into details, we can see that AS67 and 2110 also require higher clock accuracy for the GMs, for the grandmasters. So IPMX has a relaxed time specification for the accuracy, and that in turn has consequences for the capture range. That in turn may mean if you're having a GM which has the relaxed specification of IPMX, AS67 devices may not be able to capture a synchronously running stream. That's right, and so that's one of the details we probably would have to look further, but that's how it's standing at the moment. RTCP is a mandatory ingredient of IPMX. AS67 doesn't have that, but IPMX has defined that they need to operate in an AS67 mode, so the missing RTCP package should not pose a problem at all. And AS67 also doesn't specify any control means. IPMX does in turn. So no issues with the stream formats, because what is defined in AS67 or 2110 conformance level A is also required for IPMX devices. SDP information is also basically the same mechanism, although IPMX is generating much more information, but AS67 devices need to tolerate this. Basically, if you add IPMX devices to an existing AS67 operation, we should not see any particular issues, because IPMX devices are forced to lock to PTP if PTP is present. So we may see alignment timing issues depending on the clock implementation of the IPMX devices, but in principle it should work. So IPMX transmitting into such a network, only synchronous operation can work. We can't distribute any asynchronous streams. And the other way around, we don't find any issues. So any stream generated inside that stream should be receivable by IPMX. Vice versa, last slide. IPMX ST2110 AS6 device in an IPMX environment would only work if PTP is present and with a decent accuracy. And yeah, basically then we have the TX IPMX no issues, and the other way around, it's only synchronous flow which can work. In summary, I skipped that because it's just collecting this, and yeah, 6 minutes left. Any questions? Sorry for that.
Sorry. Any questions? Real quick ones. Grab Andreas after the boat if you have any questions. We're sorry for rushing you. That's awesome content. So thank you everybody for attending. And Tina, are there any instructions for getting out the boat here? I think we can just...
No, and if you have a red
I have a bad hip that's going to be replaced in about, I guess, less than 30 days now. So next year I'll be dancing here. So as a small group, please don't hesitate to interrupt and ask questions. The whole idea here. Okay. Well, there we go.
It always takes like 3 seconds of delay. Just press more. Just a lot of other presenters have been trapped.
Okay.
Hang on 1 second. We're working on it.
Yep. Okay. No.
It's loading. Give it 1 second.
Loading.
Processing.
Okay. So, just first of all, who am I? Basically, I'm president of Harper Vision Associates. I'm a senior consultant to major investment banks in the United States and abroad. And I'm also CTO of something called Gateway, which is, I'll explain in a minute. But I've had a large experience in broadcast. I was WGY TV. I did TV here in Europe, did TV all in Canada, United States, developed technology at ACTV. I have a number of patents on that area. Was part of the team that created Windows Media. So it was sort of the beginning of all the streaming stuff, etc. And senior advisor at a company called Transworld Entertainment. That's a company that most people probably don't know. I just realized I have a prop in here, so I'm going to grab my prop. At Transworld, we operated 2,500 retail locations selling video and audio, CDs, DVDs, etc. And in talking about all of this, one of the things is I've created a fully functional multi-node IPMX-based node facility in New York City. Instead of just reading about it and writing about it, we've actually done it. We've built it with help with Matrox and Jean Lapierre in particular, who's spent many nights with me trying to figure out why it works or doesn't work. But the idea was I'm a guy who likes to actually touch things and feel things and see it actually happening. It's very different when you're working in just theoretical. So I go back to 30 years from now. I thought I'd just pick a random number. And I was at the Consumer Electronics Show, and I saw this device. And this is a camcorder. Now, 30 years ago, JVC was the king of VHS. Digital didn't exist. And I got this thing, and I went, oh, it's kind of cool. And I took some pictures. And at that time, I owned a video production company. I had 5 studios, one in LA, one in New York, one in Midtown New York, and 3 down on Wall Street. 4 big online edit suites, 1-inch machines, Betacam, SP, millions of dollars worth of stuff. And walked in and I saw this little thing. I said, wait a minute, what's this? And it's a toy. And I took some video with it, and I went, well, actually, the video's pretty good. It works. So I went to NAB shortly thereafter, and this was at CES, and I went to Sony, and I said, hey, guys, what are you going to do about this? They said, no, it's a toy. No one's going to do it. No. You got to stay with the big iron, and you're a broadcaster. You know that better. You can't possibly do this. And I went, interesting. And I said, I've got all these millions of dollars worth of equipment I'm on personal lease for. Maybe it's a time to sell my company. So sure enough, I put my company up for sale. I sold it. And the company kept on going for about 3 or 4 years. I replicated the video editing system on a Mac for a fraction of the cost. And of course, we all know what happened. Digital came along, and of course, Sony adopted the DV format, and then of course all the other digital things. So I basically was looking at the future, and I think we're at the same point right now in digital and IP. So we have 2110, which is a really great system if you're a broadcaster. But what happens if you're not a broadcaster, and can you use this technology? And is it a toy like this, or is it real? And so we set out to figure out what the story was here. So Basically, I have a space at the Swedish American Chamber of Commerce. I'm not Swedish, but they needed technology. I needed space. We made a deal. And we have 20,000 square feet in Midtown Manhattan. And it was a space for Scandinavian companies to come and have a place to work. But I then worked with, actually now 87, I couldn't believe it, AV broadcast vendors to put together technology so that I can evaluate and test it. But the same token, take a look and see where it's going in the future. So it's real. In other words, this is not a trade show. This is day-to-day people using it on a daily basis. And so we've created a lab, but it's also an operating facility. So, I mean, you all know this, but you know, IPMX is based on 2110, and 2110 is a very rich format. But in Pro AV, we don't have house sync. We just had a talk about this before. You know, we don't know about that in the Pro AV world. And computer outputs for, you know, we'll have laptops. We bring them in, and what can you do if you have a situation like that? Can you use 2110? You can, but you got to put interface boxes everywhere, and then you got to lock it all together, and now you're building a broadcast facility. And what people want to do, they want to bring their laptop and plug it in and make it work. They want to bring in a DVD or a play, actually have it happen. So the other big issue is color space. If you're working in broadcast and you're at 422, not 420, sorry, there should be a mistake there. If you're working in broadcast at 422, you don't really care about that because you're going onto a TV, it's broadcast. But if you're now feeding a video wall that's 100 feet wide, or you're running computer graphics and you're sending stuff with high resolution images and you're coming out of a GPU from a laptop, all of a sudden 444 becomes kind of important. And yes, 444 is part of the standard for 2110, but no one builds that product because it's built for the broadcast industry, and we're not in the broadcast industry. So how does this actually make sense? And then, of course, there are other things like HDCP. So what happens when someone comes in with a piece of content and they want to play it? Try to run that through 2110. Good luck. And then you hook on to edits, and you want to have you want to connect it up and connect it to a monitor. Well, in broadcast, we know what the aspect ratio is and all the rest. Not so in AV. You know, we might have a 21:9 monitor. We might have it 5K. We might have different things. So all of a sudden, all these things start creating challenges, which is why when IPMX came along, it was like, whoa, this is a very interesting solution. So basically 2110 is sort of a SDI replacement. That's what people have been using it for. And I'm certainly doing that in other locations, not in my own space. And it's all locked to PTP, and you know, it works great. But not so much things that you know, you have issues of different bit rates. You have RGB versus YUV. Those are things that are in the standard, but are not necessarily things that I'm going to find in the AV space. So what we've done is we're not reinventing things. You know, it's 2110 is the basis, but we're adding. I would call it a super format on top of 2110, and we now have RGB non-broadcast resolutions. We now we do need NMOS, of course, because if you don't have NMOS, you can't control it all. But you don't have to have it very complex. You now have HDCP, EDIT, and we can start doing things that are available for an AV, and like KVM control, for example. That's stuff that you wouldn't normally have in a broadcast environment. We can also do compressed, because if I'm building a broadcast plant and I can put in, you know, gazillion-dollar Arista switches and the rest, that's one thing. But if I'm in a corporate environment, do I really want to put that in? I mean, maybe if I'm doing a broadcast facility in there, but if I'm running monitors everywhere, wouldn't it be nice if it were on a 1 gig network or a 2.5 gigs network or something of that nature? But I still need low latency, and you know, again, I don't have a clock. I can't, in my office, go stick a GPS antenna on the roof and make it work. So, so what we have at Gateway is, we said, well, let's see if we can put this together. So we have both uncompressed and compressed. So we have the same signal coming compressed, uncompressed. We have stuff with HDCP. So we actually can set that around. You can actually send that HDCP content using NMOS, and I can say, okay, send it to that Sony TV. It's going to work because it accepts HDCP, but I want to send it to the planar video wall. Well, that's not an HDCP compliant device. It won't work. We had just had the previous boat ride, we had to talk about AS67. We are interfacing with AS67, so we have AS67 running through it. Daisy chaining. So redundant paths. So in 2110, of course, we have the red-blue network, but here Matrox has put together this daisy chaining concept. So it can go this way or it can go that way. So if you cut one of the cables, guess what? It still works. So we have a lot of the features that we want to see in the 2110 resiliency that that handles the redundancy. Also, we want to be able to plug something in and not have to worry about specifying it. Plug it in and says, what is this input? Oh, this is X, Y, or Z. It's a RGB format as opposed to YUV. It is. It has the following resolutions. Again, the technology does that. And so we have an LED wall which we're running at 444. So it's a 3 megapixel and a nanolumens wall. But we also have broadcast signals. Again, why says 420? I don't know why. Anyway, broadcast signals at 422. So we have cameras and because we have event going on. And again, we're using affordable switches. We're using the Pro AV line from Netgear, and it works beautifully. So it's a pretty cool little system. So that is the objective to see, does it all work? That was the question. Can we actually make this work? And can non-broadcast people, non-engineers, interns basically go in, take a laptop, plug it in, and have it work? Hook up a video source from an Apple TV or Black Magic, $400 switcher and make it feed it. Will it work? And the good news is the answer is yes. Here is a picture. I can't take credit for this because Jean actually drew this for me. But to give you an idea of what's happening, so these are all the devices. And there actually are 2 video walls now. That's the planar. Actually, there are 3 to be actually really precise. So what we have is a combination of different things. The network, first of all, it's Netgear switches. It's a 100 gig backbone. There's 10 gig out for some of these feeds, and there's 25 gig going in other ones. So it's optical or fiber or copper. So the event space, we have Panasonic cameras. They're UE100 cameras. They're coming out at full resolution. We're putting them out, and they're going to the network they're going on fiber. We have as a cart. It's really a small production switcher, so it has production switching capability. We have other devices going in my lab, which are other cameras. This is sort of the schematic of it, but in fact, there are probably close to 40-some devices on this network that are running around. So it's hard to put all in the same thing. In my lab here, we have 4 Sony professional monitors with HDR, and we can route anything we want to that. Plus, we have an LED wall. I'll show you some pictures of it in a minute. And then we have on my desk. So I have. There are a lot of devices. And somebody counted that I had 34 cameras in my lab, in my office. That's not the whole facility. So there's a lot of stuff running around there. And of course, we have. There's also running SDI. To compare all of this, we actually there are 4 networks running. So, because I want to compare 2110, IPMX, NDI, and other things. So there's one, and I use the prefix, the numbers. So the 192 network is a 1 gig standard off of Cisco Meraki. It's just basically, for your Wi-Fi and the Zoom rooms, etc. The second network is the 10.10 network. They're obviously they're all VLANs, and that's a 10 gig network, and that's running NDI and Dante, and so I can now see what Dante looks like. The third network is the 2525 network, which is a 100 gig backbone, and that's where all the IPMX stuff is running. And then the 4th network is the 172 network, And that network is actually a proprietary system, not running a QSC system. So it's a closed loop, so it doesn't really operate anything, but to see, how does that work in that environment. So all those networks are running. Plus, of course, there's also a full HDSDI network, traditional 4 gig HDSDI. So I can compare, looking at it coming out of HDSDI, coming out of the camera directly. I can look at it on NDI. I can look at it on IPMX. I can look at it on some of these other, the NDI or the other networks. I can look at all these things, and I can compare them, and I can route anything that I want to anything else. Very interesting when you do that, by the way. So what we have here, this is the NMOS. This is just one of the panels. So we're using the Matrox the Matrox. Thank you, Conduct IP. Conduct IP. So this is just one of the pages. You can see there are different pages up here that have different parts of the room. So we can segregate who's running to what. So I don't want people in my event space messing with what's happening in my lab, or my lab messing up the event space, and vice versa. We have different capabilities here. So basically I have a series of sources up here, and then destinations. And those destinations are going to, and here's a picture of it. So there are these four Matrox boxes are driving 4 monitors. And so they're daisy chaining. They're bringing both optical and copper connections between them. And then these are some sources that are going in. These are some of the multiple cameras I'm talking about. And I'm able to very quickly go in here and, there we go. So that's an example of the wall. So those are the 4 monitors. So this one here is right now is showing HDCP content. This one is showing the output from a laptop, just plugging it in. And these two are actually synchronous with each other. And those are 2 separate forces coming from a media server, which is also driving a video wall, etc. And I can route anything to anywhere on here. And then you can switch around and see what you want on it. So that's an example of how that works. And then if I go over here, so this is the rest of my lab, and as you can see, there's a lot of stuff going on in there. So it's Matrox IPMX routing. There are actually 32 cameras, I guess. Planar color light, that's the planar wall right over there, LED wall. Sony HDR monitors, D10 dual screen. Now that I've not figured out how to get IPMX into there yet. I really love to see some monitors with direct Ethernet connections into it. You have, there's another view, you can't really see it here, but I've got LG Magnet, which is their LED wall. It's a 0.9. I also have I've got, obviously the things like Crew, Logitech, Rally Bar Pro, etc. And all those sources can be, I can route some of that stuff into this IPMX network, so I can intermix AV type gear with broadcast gear. There's a megapixel Ventana system now that is also bringing in content, and that's a 0.87 pitch thing, and then bunches of cameras, audio, Odessia, for Yamaha, Salomon. I mean, there's, as you can see, a lot of stuff. And then here's another picture of the lab here, and you can see what's going on. So here is the rack with that's the color light processor. So we just plug Ethernet right into there. That's the megapixel processor with this little routing switch, and then a whole bunch of encoders here for getting signals out. And then that is the Ventana. That's over here is the Magnet, and then all these other monitors are things. And of course, there's pro capabilities. There's a TriCaster. There is Panasonic Control, Blackmagic, and even down here are broadcast cameras when I need to use them. So it gives you an idea. But we also are using this to talk to other spaces in the thing. So in this is the boardroom. We have a 32-foot, 32 by 9, 16-foot LED wall that's driven by megapixel. That's also now, of course, on the network. We have an Barco E2 processor, and so we're taking the output of the E2 processor and putting it into encoders. We're shipping that around. We have this content here is coming from Immersive Studio Design. That is a server. It has a 100 gig output on that. That goes in the network, and I can put that out. That's actually coming out 2110. There's a 7-camera Crestron One Beyond system in there, so the multiple cameras will switch, so this is Crestron automatic switching. Then the microphones, audio processing, MTR, Zoom rooms, ClickShare. All of this can be switched around easily. Right now we're using this Stream Deck to switch things here. So that's just a control. It controls a little PC. It's driving the Barco E2. But again, that is the type of stuff we want to run on IPMX, and as we keep on going on it. So this is a real AV environment, and it's running every single day. It's not like we set it up for one thing. We actually use it every single day. And there's another room here that's the event space. And here's an example. This is a 21:9 touch screen. That's a regular 16:9 screen. We have LED lighting in here, projection. That's the event space, and there are cameras in there. We have another room with another LED wall. That is a Barco. That's a 21:9 wall. Again, those are the things that you just don't do that in the world of 2110. You have all this capability. Without IPMX, this would never happen. Then there are other conference rooms around the space. There's a front lobby and other screens of different types and all different forms. So, anyway, that's basically what we're doing here. This is what the back room looks like. There's your Netgear switch, processing. There's a whole Blackmagic switching here. Those are the servers that are driving some of this content, and we are running to the end. So the partners today, obviously, there's Matrox, Netgear Pro AV is involved in this, Color Light Planar, Megapixel with nanolumens, Barco, and we have some Barco products that I can't talk about yet that are exactly accepting full video coming in, Immersive Studio Design, which is the server, and then the party is coming up for Evertz wants to join, Plexus AV, and anybody else who has IPMX things that wants to come and join. It's an open forum. Come on in, look at interoperability, see how we can make it work. So thank you. Again, if anybody wants to join our sandbox and come and see it, it's in New York City. It's open all the time. Just let me know. Thank you.
Thank you, Greg. Does anybody have any questions for Greg? Yeah, 1 second.
Yes, hi. Can you just tell us how we can visit that?
I'll give you my card, give me a call, and come on and see it. We do actually do industry events. I'm going back on this Wednesday, and Thursday we have an industry event there.
Because there's a medium-sized show next month about AV in New York.
Yes.
Are you planning something
yes, of
around
course.
that?
Yeah. Well, I'm sure there's stuff going on. There'll be people there. But yes, you're more than welcome to come.
Okay, cool. Excellent.
Yeah. And also, if you have product, or if you want to try and see how to interoperate, the whole idea is we're not Switzerland, we're Sweden, but we are open to everybody. So anybody wants to come in and if they have a product, see how it works, see how it happens, do it, bring it in.
Any more questions? All right. Thanks a lot, Greg.
Yep.
Fantastic.
Okay.
talking about time again, timing in my few minutes. All right, awesome. Thank you.
Okay, hello everyone. This is not intended to be a deep dive PTP session because not everybody in the industry knows all about PTP. three sections to this session: time and why it matters to us, how PTP addresses it in our 2110 space, and synchronization in the wider ecosystem enabled by IPMX that we've just heard explained so well. The time, we watch it, we spend it, we waste it, we lose it, and with so many verbs it's got to be important, and of course it is. And a candle, oh, let's see, I need that bit. Time.
There's a bit of latency.
There is, isn't there? So, candle clock, like this old German one, helps us to visualise the local time, particularly at night. But it doesn't really do anything to help us synchronise things, and even manufacturing variability of the candles. That's going to make it different from time source to time source. Candle clocks like this one, got to mention in Japanese and Chinese literature from ADS 520 onwards. In Europe, the references tend to come a little bit later with King Alfred the Great, who was an Anglo-Saxon king in a region that was ultimately to become England. Some of the candles had different colours in them, like blue and white, to symbolise the passage of time. That was the units of time, moving from blue to white. Time's clearly important to all of us. So moving on from deep history, how did it move on? Doesn't look nearly so exciting, does it? That's an atomic clock, in this case an old rubidium one. And this is a cesium clock. The top 19-inch rack is the clock, the bottom bit's the power supply. That was designed in the 1970s, you can probably tell, but it was still being sold in the 80s when I was at RNS. That's an RNS unit. Cesium clocks are primary standards, rubidium clocks are secondary standards. The difference being you don't need to calibrate a primary standard, it doesn't take reference from anyone. Rubidiums tend to get built into things like transmitters, where cesium clocks tend to go into calibration labs and so on, and reference national standards labs. They both look a bit different now. The essential ingredient, the gas cell, the vapor cell, is about the size of a grain of rice, just to put them into context. As a matter of record, these are frequency standards, not time standards. But we all know that one is the inverse of the other. They both work by aligning an oscillator to transitions in gas molecules, transitions between different energy states. If you excite the gas, maybe sweeping it with an RF signal, that's why RNS was involved, the energy changes, and that transition always happens at the same frequency. And the second is defined by counting the number of transitions. So it's very, very simple. Given that we've had the candle clocks for so long and all the other time sources, cuckoo clocks and the rest, seems a little bit surprising to most people that the second defined as we define it today didn't happen until 1967. Some of us at this end of the boat are older than time itself. Sorry, Greg. There. So time code has been with us for a long time in one shape or another, and in this industry we do love our acronyms, don't we? LTC, linear time code, VITC, vertical interval time code. We've got it embedded in our AES signals. We've got control track longitudinal time code, BITC, burnt-in time code, visible to everyone because it's in the picture itself. And of course we've got lots of media critical time and frequency related aspects. We've got our sampling rates, our pixel clocks, our line and frame rates and so on. And it's important. How does it affect us? Well, the industry has used sync pulse generators, and I'm responsible for having sold a few over my time, to create multiple, say 6 or 8 timing planes within a facility to allow for transmission to sources across cables of different lengths. We're moving away from that, as we know, from SDI to IP. That's why we're here. That's at the IP showcase. And this is offering, amongst other things, the promise of unlimited timing planes for our media. Now the standards and specs that we look to are our own, such as ST2110. We've heard a bit about that today, of course. But when it comes to timing, that itself invokes other standards like Precision Timing Protocol, PTP, which is codified as an IEEE spec 1588. And more recently, IPMX, as we've heard, using the VSF's TR10, an extension of ST2110 into the AV space. And it's supporting exactly the same thing in order to be directly compatible with 2110. That's an important. Additionally, IPMX devices have got other timing modes that 2110 doesn't have. And that's what we'll be looking at a bit later, moving into part 2 of my 3 now. PTP, as we said, is an IEEE standard. It's 259 pages long, and I'm certainly not going to read through that for us today. Very few of us, especially me, but maybe there's one or two in the audience who could read it. Yes, I'm thinking of you. could actually speak to it word by word, but it doesn't actually matter. The current evolution is known as PTP v2, which unfortunately is not backwardly compatible with v1. Significance difference is how the timing leaders announce themselves. So reading from the spec here, it's a protocol to synchronize real-time clocks in the nodes of a distributed system communicating on a common network. And that's what we've got, of course, isn't it? If I asked you to name a few distributed networks, you might say IT, industrial, power, AV, in-car. Some of them are media related. They all want precise timing, but they've all got different ideas of what precise means. PTP has got a lot of options, not all of which are applicable in all circumstances, but it allows different configurations. So for those here who are new to PTP, don't be tempted to think that PTP compliant is the answer to everything. It's not a sufficient description. There needs to be a bit more detail. The standard allows a latitude broad enough to be widely applicable as a standard, and the profile restricts the parameters to a narrower range specific to the industry or to the application. And for us, this means carrying the media of related timing across our network as we evolve, of course, from SDI to IP. For the new, you also need to be aware that PTP is advanced networking. It's not general purpose networking. That's important because if you use your corporate IT department or IT person in a smaller organisation, it's unlikely they're going to know what PTP is. You know, you don't find it in the CCNA syllabus, for example. Across all those industries I mentioned, PTP exists primarily not in IT but in OT, the operational technology. Important distinction. It's where the network is specialised to the functions, the operations they're doing, like moving media. Also be aware that some of the media over IP systems are using PTP v1. They are now technology islands. Important to understand that. So, we've all heard synchronised watches. You know, it's a classic of Hollywood. It's used for synchronising activities that are going to be happening later on by different people. The phrase itself started in World War I. It was coordinating the artillery bombardments and the foot soldier movements. If you moved too early, it was positively unhealthy and dangerous to health. You know, we can see the importance there. It didn't actually matter what time they moved, so long as they moved at the same time. The artillery commander's watch, of course, was the ultimate reference. When he said fire, they fired. Subsequently, the phrase, of course, meant military precision. But individual watches have different mechanisms. They drift some forward, some backward. So it's important how long ago the synchronisation happened. And in that World War I environment, it was morning orders. They did it once a day. Of course, we're all used to having our clocks at home synchronised on DAB. We don't tend to think about synchronising our clocks now, but in the media, it's still important. Now, you don't actually, I said you didn't need to know the exact time. If I sent you a postcard through snail mail and it was dated 3rd of March, you don't know what today's date is unless you know how long it took to get to you. And alternatively, you could look at the postmarks and say, oh yeah, that's when it came through London, that's when it came through Chelmsford and so on. That might give you a clue as to what the time was. And you'll see that as we move on. It's not just old stuff. In sci-fi films, they still say, on my mark, mark. That's synchronising, just using different words. So, it's It's not part of corporate IT. It's advanced networking. NTP is something that the IT people do know about. The individual computer sees a server on the network, and the NTP is free. Almost every application has got an NTP client in it as well. Isn't that good enough? I beg your pardon. That's where I wanted to be. The NTP syncs to about 10 milliseconds. That's pretty good. It's good enough for getting all the computers in the room synced together. It's intended for that. It's not. Oh, it's not intended for the sort of applications we've been talking about. PTP improves that accuracy to 1 microsecond or thereabouts. We're talking about 5 zeros instead of 1 zero. So it's big difference. Who might want that better sync? Well, of course, manufacturing. We've all seen rolls of newspaper print going round and round. If you don't get the coloured ink synchronised, the newspaper looks funny. Computerised stock trading. It's important you don't try and sell something that was sold 10 milliseconds ago. So that's the way it moves on. Oh yes, and us, the media networks, of course. ST2110, as we said, invokes PTP via ST2059. And ST2059-2 includes a profile that they created specifically for it. You'll hear lots of mentions of clocks. I'm going to talk a bit about clocks now. Everything's referenced to a fixed point in time called the epoch, and the epoch is midnight on the 1st of January 1970. They're after us again, Greg. That's when time started. The clocks all show the elapsed time since then. It's atomic time. It doesn't take account of leap years and so on. And this is showing us a single PTP domain. There might be another one next door to it with a different timing leader. If something went wrong with one leader, the other one's not affected. They're referenced. Domains can be on the same network. They're given a different number. Now we need a reference time source, the best we can get access to. And up here we've got connected to the GPS antenna. The reference doesn't need to be at the top. It's just how it's been drawn here. Below that, we've got cascading layers. You can see that the red and the green network are dependent on the blue layer, and all the clocks are related to our timing leader at the top there. And that's the one that's got the best accuracy because it's connected to the external reference. Clocks don't need to be separate boxes, of course. These ones down here might be built into the switch, like we heard earlier. And that, of course, makes the PTP-aware switch a bit different. Yeah, and a bit more expensive than the vanilla ordinary network switch the IT folks need. So our ordinary clocks, they're either going to be right at the top or right at the bottom. And they've only got one timing port, a leader or a follower, out or in. All the others have got 2 or more because they're intermediaries. The ordinary clock is typically going to be part of that functional or operational kit. The transparent clock has got 2 ports. Yeah, it's a joiner. It takes a PTP message in and updates it and passes it on. It's an extender. Although 1588 defined 2 modes, we only find one of them in the SMPTE world, and that's the end-to-end environment that takes notice of the residence time it's spent in the switch and so on. And a boundary clock's a joiner. It's joining networks or separating them. It's distributing its signals to multiple downstream devices, so it may have more than one leader port, hence it's a boundary. That can reduce the length of the timing chain. Of course, switches and routers are going to be boundary clocks once you think of them that way. And all of those ports are going to have a status. They're either going to be a leader or a follower. I've added that to the diagram there. Note the transparent clock has got its letters in brackets. That's because technically it's transparent, hence the name. It's not a leader or a follower. It's passing on what came from above. And our boundary clocks will have more than one port. And in that leads us to the idea that it's not the clock that has the status, it's the port that has the status. So our boundary clock in the middle of the image here, that's got 3 ports, 1 follower and 2 leaders. Seems a bit odd perhaps that the follower comes above the leader, but it makes sense in context. It's following the timing leader above and it's leading the ordinary clocks below. These ports used to be known as master and slave, but for political reasons now that's not the right language. But the one at the top is still known as the master, and the selection is still known as the best master clock algorithm. Notice that the upward links are all one-to-one, whereas there may be one-to-many going down. Also possible to include redundancy as well, so you can have a clock that's capable of being a master that isn't, that's going to switch over to being a master later. Whilst it's not actively behaving as a master, it's not sending out the messages, that's where the passive port comes in. It's ready, but it's not doing something. When you talk to the network people, you'll hear a lot about leaf and spine in the network, and timing can follow that as well. So you can get the same sort of timing arrangement going through. This is such a redundant arrangement. We heard earlier about blue and red networks. We're doing the same thing here. So you've got the endpoints of the leaves, and the network's the spine, of course. Again, you can have the different domains on the same network or on different networks. So we mentioned profiles. Let's look at that a bit more. As we said, 1588 is generic, and I mentioned a few other industries using it. And 1588, 2008 introduced the concept of profile to allow particular combinations of options and attribute values to an application. We are using it for our own purposes, and we have got our own industry profile, known by most as the SMPTE profile, because they wrote it. And the purpose is to convey the metadata that is needed for the sync and the labelling of our audio and our video. The profile typically restricts the possibilities in terms of algorithms that are used, ranges of variables, default values, and so on, and indeed mechanisms that might be used. So what does SMPTE do for us? That's what SMPTE does for us. There isn't just one best master clock algorithm, but this defines the particular way that it's used in our industry. We tend to use the default from 1588 where we can. No point in reinventing the wheel. And our profile obviously starts restricting some of the values. We said domains could have a number. There's a default number. The default number is 127, so that you can choose numbers that are higher and lower. They can be configured as follower or follower only. That can be either a true or a false. It means it's either capable or not capable of being a leader. And it makes sense if you've got an ordinary clock. You don't want a low-grade clock to assume leadership unexpectedly. So you want to be in control of that. The leaders send out messages called announcements, and that governs how quickly the best master clock algorithm can reconfigure our system in the event of a change. A lot of the values are actually logs of something, so that if an announcement is happening 4 times a second, that means it's every a quarter. Log 2 of a quarter is -2. That's one of the values that fits in there. If it was 8 times a second, its value would be -3. And that's combined without speed of sync, the rate of messages coming out, and again you've got that 1/8 of a second sort of size time and a value of -3 going with it. Determining which of the grandmasters is important. That's derived from clock quality, how quickly it responds to a change. A slow change would be continuous. A quick change might be a step change. That might be a problem. The quality is a multi-factor consideration. Its accuracy, its stability, and a unique identifier. All other things being equal, this thing is decided on who's got the lowest MAC address. So that's quite, when you think it's the timing leader, that's quite interesting. So, is that it? We've got SMPTE profile. Part 3, IPMX timing. IPMX was created to be compatible with 2110, means you can put an IPMX RX device on a 2110 network with impunity, and it will be able to decode those 2110 essences. And remember, we spoke about the timing planes. If you've got multi-receivers, they can be adjusted through the link offset delay to address that. Remember we said PTP was OT rather than IT? Well, much of the AV world uses exactly that. Simpler is better, and simple doesn't include PTP. So IPMX has to work with those networks too. And that means IPMX devices, if they see a PTP leader, will respond. And if they don't, they'll flip over into asynchronous. Asynchronous, just like HDMI, fits naturally. Is that it? Well, no. There's a third methodology, and that's to work with a different profile, the IPMX PTP profile, which is a slimmed down version, a lighter version of SMPTE, so that the endpoint can assume leadership without having to do a lot of extra work. Clearly, that makes it important. You don't need the second, the expensive net text to do it. Final slide. Timing's obviously important. We've moved from candles to IPMX in one presentation. We started with the conformance, meaning IPMX devices can sit on the 2110 network and behave like 2110 devices. We've got the total opposite, the asynchronous, where it will do its own thing based on its own local oscillators, and we've got that IPMX profile, that's the bit in the middle, that will use the what's there. It will benefit from an PTP aware switch, but you don't need one, and you don't need an expensive technician, and that wraps it up.
Thanks, Rob. Okay. Do you have any questions for Rob here? All right.
The one and only question.
42. Oh, sorry.
There you go. Now, talking about PTP domains and profiles, I mean, the only real discrepancy between media default and the SMPTE profile is this, unfortunately, this number, the 127 against 0, and people always have to decide which one they have to go to. So question is, why did you choose 127 while the other ones were already there, and would you do it again?
Well, I think 127 is the one in the middle. Yep, it allows higher and lower.
For IPMX, since we wanted to use the profile of SMPTE, we picked the profile of SMPTE, right?
Again.
As the default. It's just the default.
Yeah, I know, but
sorry.
If you want to interoperate with others, it's the one and only. You find matching parameters with everything else, but not the domain. You have to make a hard decision. Either you're going to 0 or 127.
But there's nothing in IPMX that says you can't use 0.
Yeah.
So my device can use 0, their IPMX device, and it works.
Yeah. Controversy. All right.
Sorry. So we set out to make IPMX backward compatible with 2110. So we took everything in 2110 we can use. We only changed what we absolutely need to change. We absolutely did not need to change the default domain.
My question was more relating to even when 110 was invented, because back then it was already clear that everyone else was on 0. So that's magic. I just don't know whether it was.
I wasn't there for 2110. It's not me.
All right. Well, thanks everybody. We're at the end of our time here, so we really appreciate you coming on behalf of Ames, AMWA, and BSF, and have a great rest of the show. All right.
Thank you.
Not sure. And I would like to thank you on behalf of those three organizations for taking time out of your busy IBC schedule to spend an hour with us on the canal boat. What we're going to do is have two speakers, 20 minutes each, and hopefully a few minutes for questions and answers before we return to the dock. It's an electric boat. It's pretty quiet, so we're not going to use the speakers, but we are recording this, and we'll make sure that we have these available as soon as we can after IBC. All right, if you have any questions, please let us know. Our crew is Marta, and that's our skipper, and that's Michelle. And Michelle will be bringing out coffee and water, and please help yourselves to any snacks. All right? Thank you. Thank you so much. Nicholas, take us away.
Yeah, sure. Hello everybody. So let's speak about the network. It's changing the topic of the whole day, of course. But it's a use case, it's a user story, and it's not mentioning branding at all. Although this presentation is sponsored by Director of Technology, and during the presentation I will speak about audio bridges, etc. So those are not the ones used in the presentation, but those are obviously the best one because they are the sponsor of this presentation. That being said, no more marketing anymore. Subsidiary disclaimer is, of course, this is inspired from a real case, but this is also expanded. So, as we say in the movies, no relation to actual person, etc. If the names were changed, etc., etc. I say that for my colleagues who I work with, that so that they don't take anything personally, because it's a tough subject. It's the subject of AV and IT and working together with AV and IT. Of course, we would like to see the AV world as big as that, but it's really small compared to. There's a bit of latency that it's breaking the dynamic of the presentation compared to IT, of course. And we wish we were here, okay? But as a matter of fact, we are actually here. We still need bridges in all the meaning of bridge to do the communication between AT and IV world. And then that being said, it's killing the. I will find a way to keep the. I'm Nicolas Sturmel. I'm a tight Cat 5 worker, so that's like a tightrope worker, but on a Cat 5. Hence my condition. No, I'm kidding. It's a bad joke. It's a bad joke. So I'm a media network consultant at NSI Squared Consulting. That's my private company. But of course, I'm a network technologist at Director GmbH. That's the reason I'm here. Director is the most part of my work. IT management, music production, broadcasting, development, project management, etc. Name it, I can talk about it. I'm probably not the best at it, but I know a bit of everything. I have a PhD, but who cares? So yes, what we will talk about today is the prerogatives of AV, and IT, and we will do a reality check. So we will see why I was called to this project. And how we solved the project by analyzing the topology, the problem they had, and how we made it simple. Because basically that's it. If you want two teams to work together, they need to work on a similar context, and you have to strip it away. You have to simplify it. So, of course, there are remaining issues that we will speak about too. Okay. It's actually good that it's slow. It makes me speak a little bit slower as well. So this is a presentation made in the way of the persuaders. If you are old enough to be liking all the UK TV shows of the 70s, you might have heard of the Pacer Brothers. In French, Amicalement Vôtre, and in German, Die Zwei. Yeah. So two brothers that do not share anything in common. Okay, IT is really owns the network. Okay, IT is the network providers, while multimedia is the network user, but it needs the network right now. Okay, you cannot do multimedia without the network. IT does horizontal management. It has a lot of different customers and cannot privilege one customer over the other. The problem of the IT team in big organizations like the one we are talking about, which I will not name, they have a lot of different customers, and if they begin having a priority policy, every department will come and say, why am I not the priority? So they tend to be neutral, and this is problematic for the media networking, because media networking is a special network, a real-time network that needs special taking care of. Multimedia obviously does vertical management. It's just interested in its own verticality. What am I doing? What am I producing? How can I produce best? IT does all-purpose networking, and multimedia does real-time networking. And this is a dramatic difference in the way you see the network, in the way you deal with issues on the network, and how you monitor the network. Rule number one in IT is security. And this is the rule number one. While in multimedia, it's operations. In multimedia, they want production of the content. If they have to break security to ensure that they will be able to run a meeting or a show, they will break security. Security is not their highest priority. While IT doesn't care about the show or the meeting. So I will describe this later. But the meeting cannot happen from the IT point of view. If security is not there, the meeting cannot happen. From the multimedia point of view, if there's no network, I don't care. The meeting needs to happen. Okay. So too many times, IT has been annoyed by naive users, by users that is too many times annoyed by naive users, new users that really don't take the effort of minimal understanding of IT, which is usually not the multimedia team, but I'm talking about horizontal management. While multimedia too many times has to fix audio glitches, and they are often caused by the network, but not necessarily, but it's always easier to blame the other part. So, and because you don't understand, so I don't understand the network, so there's a problem, it must be in the network. In the end, IT, zero user trust. My users of my organization, I don't trust them. So I will lock everything I can lock for them to not be able to wander outside of the process. While multimedia has zero network trust. Have you met someone at the show, a user, that says, I don't need redundancy on my network? Okay, by this very fact that we use network redundancy, it shows that we do not trust the network. But of course, this distrust goes way beyond that in this case. So yeah, Brett Sinclair and Danny White. It's the metaphor about the 70s shows for the youngest one of us. So IT has the security prerogative, multimedia has the operational prerogative, and those two make media over IP. You cannot do one without the other. You have to have security. And security, again, security in the broad sense of term. Security in the fact that it is about designing a network that works in the long term. And so there's a tension between specification and reality. The IT will specify, okay, there's a new project, there's a new meeting room. IT comes and say, okay, we did this addressing scheme, we will break things like that. And defining IP addresses, layers, network, firewall rules. Multimedia take care of the installation and the operation. And most of the time, I have no access to a network. I have multiple VLANs, for instance, and I miss access to a VLAN. What do? I add a USB Ethernet converter to access the VLAN directly. This is a security flaw, because the computer using like that can serve as a bridge between two networks. No time to set IP, because operations. Who has time to do operations? No time to set IP. Well, automatic addressing will do. Yes, until you have to do debugging on your network and maintenance, etc. No device monitoring, no access rights. So everybody has access to the device all the time, and that's also a problem, because actually what we saw is that most of the errors were from users misusing the network or misusing the different parameters. So reality check. This was, of course, an extreme case, but you can find threats of this tension in every installation. I dare anyone to tell me, oh, we had a project and IT and AV were just friends during all the time. So now we will take a look at this precise example of a non-governmental organization that deals with many meetings a day. So there are 4 locations and 60 plus meeting rooms with outside AV contributions. We have the central venue, which has the master control room, 1 big meeting room, 30 meeting rooms, small meeting rooms, and 1 core switch. And this is the core switch for the whole campus. So 3 other locations, each one with 5 to 10 meeting rooms, and as I said, the uplink to the core switch of the central venue. It's a standard architecture, but for non-media over IP. Of course, if you do media over IP, you tend to not route directly to a center switch. You will have multiple layers of routing to optimize the media flows and the bandwidth. Okay, so a typical meeting room looks like that. I mean, from my point of view, of course, not from the point of view. Sorry. A typical meeting room server rack looks like that. So we have a conference system, we have an audio system, we have a video matrix. Basically, it's a meeting room that records video, that records audio, and because of the outside contribution, all this audio and the video is made available through a meeting conference system. PTZ cameras, an audio matrix, an audio bridge for isolation, I will talk about that later, and an outside contribution system. So usually a video conference PC. But this means that there is one PC that has an internet connection. Again, a security risk. So the problem is that all meeting rooms are isolated. So the story is that they started very naively by putting everything on the same network, /24. And at some point, there was too many computers. And they began to have problems of side effects when I change one. It's an audio over IP network. So when I change one device, or the PTP master in changing configuration issues. So they went to the simple solution, okay, each device will be an isolated network. Isolated, so nothing coming out of this network except audio. And how do you pass audio between networks without connecting the networks? via the audio bridge I mentioned before. So it's one device that has two audio interfaces and just passing back and forth. That's I'm explaining here. That unfortunately adds a layer of routing. So it's, for me, it's a difficulty rather than a simplifying the problem. And of course, because the network is isolated, you are blind of what happens on the other side of the bridge. So you want to do maintenance, you have to go to the meeting room. Someone calls you and say it's not working, you have to go to the meeting room. That's not really networky. Random clocking errors, especially because the bridges they use were having no SRC cards. So they had to have a specific clocking scheme, and it was easy to break this clocking scheme. Very, very easy. Some rooms share the same VLAN because it's an ongoing work, so we went to the point where some rooms shared the same VLAN, and this meaning that you could access the equipments of one room from the other room. And this is problematic because it breaks the fact that each room should be isolated, but that each room should be its own production environment with its own users and its own practice. And prior consulting led to eliminate some evident solutions that we eventually use. So this is the, and I'm not, of course I'm rooting for my side, but this is not even the point here. The point is that using the right consultant is important, and not choosing some random company that has no experience in the network. They used an AV consultant that had no experience in the network, and of course, this consultant chose simple solutions that he could understand, rather than doing this bridging between IT and AV. And there are plenty of consultants that do IT and AV. So again, not a private publicity. Okay, so the main problem was isolation. You lose visibility, and this loss of visibility means a loss of implication. Okay, if I'm in the master control room, I don't know what's in the meeting room, so I don't care. IT doesn't see the network, so IT doesn't care at all. It's your network. Do what you want with it. The bridge solution fixes a problem that could be solved more gracefully, and this is a typical network convergence problem. When I have multiple networks, when I have multiple media on the network, it's always easier to have completely isolated VLANs or isolated networks, physical networks. But this is not the solution, because at some point you will want to unify the control or to be able to exchange media between those networks. So IT says, I give you a VLAN, you do what you want with your VLAN. Multimedia say, okay, IP power will be good enough, I just need to pass audio. What else can be wrong, okay? This network, this technology they use here is known for its simplicity. So of course it will be simple. When we scale up, of course it will be simple. So we worked toward a better solution. And this better solution was a need of supervision and resource sharing with security and documentation. This seems bluntly obvious, but it has to. We had to work toward that by learning each other prerogatives and ecosystem. And this was training of AV of the IT team, and training of IT of the AV team. Of course, not training to an operational level, but training to being able to understand why does my colleague reply to my question like this? Why does it not allow me to do what I want to do? The management software and the layer 3 architecture. So obviously, you may have understood by then, no more isolated networks. All networks are routed together so that everything can be managed through the master control room. And a persuader, an individual fit for communication that does communication between the two teams. And that's not the consultant. That's someone in-house. If you take the consultant to do that, you are basically hiring someone else.
Someone from the AV team?
And it was someone from the AV team, yeah. It was someone from the AV team with a good understanding of IT, not at first, but also a good envy to learn and a curiosity. Curiosity, basically you choose your people by having curiosity. Some people are good for production and they are the best at doing AV content. And some people, like me, I am one of those, they are very curious but very bad at delivering. So, documentation and process. This is the key. You want to, because basically the AV guys, and I guess there are a lot of those guys in the boat at the moment, we solve problems all day. So I would call them every 2 weeks or every month and say, how was the last days? Oh yes, everything was good, we had no issue. And then we continue discussing and yes, so this was not working and we had this issue and we had this cooking. But they don't think about it because all day long an AV guy is solving problem. He's focusing on content delivery. So if delivery is not there, he has a job. So the whole job of an AV guy is solving problems. So being able to document those problems is important. But this man in the middle, the persuader, is a unicorn. It's difficult to find people like that, immensely creative, problem solver. Yeah, and that's what I wanted to do. So on the AV side, we have immensely creative people with a problem-solving ability, and on the IT side, we have a rigorous capability of building a runtime and maintainable network. And this unicorn must have those two qualities. Okay, you have to know the, and I see some here, but the person should take on the project management, handle the requirement definition and the achievement for both teams. So this is the difficulty because it's someone that sometimes feels like it is betraying his own side because he understands the need of the other side to advocate for a different solution. So yeah, crucial ingredients for a successful project: people. Who would know? The right people would help into making a project successful. Okay, so yeah, the transition process. So this was done during 1 or 2 months. So we were configuring. Oh, there's a branding here. We were configuring the software with user and roles. We're configuring every device during the downtime on the AV activity, and we also did testing and validation, obviously, and a process to under print cases, because by doing this overall reconfiguring of the network, we noticed a lot of incoherencies that just weren't there. Bad firmware version, impossible things they thought that it was able to do. And the process was as simple as a Excel sheet with, this is the device I have on the network. This is what I'm expecting on the network. And the IT says, cool, I know what device you are using. I know the address of the device. So what will I do? When I will see something bad on the network, a bad device, a bad behaving device, I will tell you, you have a problem on your mixer. You have a problem on your PTZ camera, for instance. So again, very simple. One of the switch firmware problem we solved, thanks to PTP analysis tool, we provided the capture to the IT team. They said, okay, now I see the problem is on the network, so I will fix the problem. Again, just being aware and communicating. So yeah, you saw the big matrix. this is what one user on one meeting room was working on. Okay, tell me tell me you don't do mistakes. And by using a magical software that stands in 3 letters, we came down to just what is needed for the meeting. And because this organization is using a lot of outside people to run the meetings, it's really important to give the users just what they need and not too much and not too less. Yeah, so Kiss and Do 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 is the Kiss reference to the Kiss song. So the benefit of the transition, the DMCR can view everything. It has all the status. And even though this wonderful software is wonderful, it was missing some features. So I did also a bit of custom software for them to be able to note when a room was actually off the system. So when some devices were off, like turned off, the room was marked off, so that the errors coming up from the software were ignored. The number of bridges were reduced. So all of the bridges, mostly all of the bridges, were deleted. No more use of bridges. We have layer 3 and layer 3 clocking. So very cool. And less failure points. Less bridges, less failure points. As much as I'm sponsored by a company that sells bridges, when you don't need a bridge, don't use a bridge. Control can be done through other VLANs. No need for USB to Ethernet adapters. We had octopuses computer with 4 or 5 Ethernet to USB converters. Tech support is easier, of course. IT and media have communicated. They have done the project together, so they exactly know what's happening. So now a simple message on Teams, and 3 minutes away, 3 minutes after, the switch is configured or the information is provided. Simple. Full control. Unregistered devices are not allowed. Clocking config cannot be changed. This is the security part of this management software, and less user error because of what we saw earlier. Not everything can change, and not everybody can change everything. Okay, and we are getting to the end of it. Yes, clocking is still a problem because we had enough PTP presentation right now, so those who are not in the 2 previous sessions, you can look at them on YouTube when they will be out. But the use of PTP can still be problematic. So for the big meeting room with 500 people, we are still isolating that clockwise. So we are still using a bridge for this, just for safety. But still, the use of PTP v2, clocking through layer 3, etc. And especially this management software will indicate clock mismatch. The number of times they had the clocking problems and didn't know where it was or how it happened. Just knowing which device what device slave device is listening to, this already solves half the problem. And okay, so unfortunately, some device needed a control software that could not work outside of a LAN. But this is old devices. Some workflow can only do unicast at layer 3. So this means that you cannot use multicast, you have to use unicast, and the resource management can be more problematic. The integration work is sizable, so yes, you need specific tool to support the workflow of the team, but this is what APIs are for. And the virtual drivers and firewall, this is a nightmare, because virtual drivers are, so we are talking about AOIP drivers, so they are using the network in a non-conventional way and trying to set up the firewall with the drivers is also a hassle between AV and IT, because IT is asking, but why do you need it? Why do you need it? Why do you need multicast? Why do you need this port, etc. So it was complicated, but eventually it was done. Okay. So overall, it's quite a success. A lot of things that were learned during the project, and I have to say, all the people involved in this project were really open in discussing. So it was not a trench war where everybody was fighting for its own side. I tend to present it like that to stress on the differences. But the team that was involved in this project was really open-minded. And this is key for the success. On the other side, right across the river, there is another European organization. What they choose is just use a different network. So they have their own small network for AV. They are not using the IT network. And this, from my point of view, this is a mistake, because you are losing all the security aspect, all the help of the IT, because you cannot speak with the IT team. You are blocking yourself from all those competences that can help you success the project. Okay, any question?
Thank you. I'm Clement. It happens to work for the European Commission, so your topic is right in the right place for us. I'm curious, at the end of a successful project like this one, do the IT people feel more AV and the vice versa, or they remain in their feelings separated?
No, there is a growth in both ways, in the fact that they are more aware of the need of each other. Of course, the IT team remains focused on the horizontal perspective because it has to. But the AV team has learned a lot in IT, and especially what I like to do to take to my students, you have to learn, because I'm teaching to sound technicians, you have to learn what you cannot do in IT. Just learn enough of IT to know what you cannot do. And now the AV team is asking the IT team more often, and this strengthens the trust between the two teams. And this is it. This is the trust. When you can trust your colleague to do things when you ask him, and it's not, it's a trust is something relative and really it's a feeling more than ever. So when you have this feeling, you're working more gracefully.
Thank you.
Thank you.
Any other questions? Thank you very much, Nicholas.
Thank you.
We'll invite Andy up.
Is everyone up for doing a selfie with me? I think it's sometimes fun. Okay, here we go. Okay, yeah, get in. Get in there, Nicholas. Here we go. Thank you very much. Wonderful. Okay, I think I've got the dubious pleasure of being the last presentation of the day. Should I?
That's all that happens.
Thank you, Tina. Shall I come and stand this side so you may be able to see it better? I'm hoping my transitions are a little bit quicker than yours ended up. Okay, so a few quick things. Are we actually up and running? How much is the latency on this? I thought I'd just show you.
It's about 4 seconds.
I just thought I'd show you my little journey. So this is the shortest path I've ever done to Amsterdam. I've typically flown. So this is my direct route from Felixstowe in the UK to the Rye, and actually that was my path. So train to Harwich, then the ferry to the hook and up on the train. So that was pretty good. So the shortest path does work, although that bit was quite slow on Wednesday, I think. Anyway, that's how I got here. I've been with Appear for almost a year now. So last year when I spoke on this, I was speaking for a different company, but I soon joined Appear after that. Just want to give one company plug. First of all, I do a regular podcast called Time for Tea with Andy. For those of you that know me, I have a bit of a passion for cups of tea. Adequately serviced by the great team here. Also, if you have a chance before you leave, do come and check the Appear booth, which is Hall 1B41. It would be good to see you there. So that's the commercial over, and I will jump into what I'm going to be talking about. So I want to give you kind of a resume of quite a few topics related to time and timing and latency within audio production. So a few people from the history of the world have had some comments on time. I've used some of these quotes before, so it's not new, but I want to cover everything from looking at latency requirements, looking at the criticality of different elements of timing within workflows, including alignment of timing, and also the standards work that's going on. So I'm trying to do kind of a quick dive into some of those bits as we move forwards. So a couple of generic just placeholders, if you like, for expectations. First of all, what are content producers wanting to do with live production? In my mind, there's always three tenets of what they want to do. They want to reduce the cost of how they're doing stuff. They want to up the production value. So they want to be able to be more creative with the budget they've got. And therefore, they want more flexibility in the way they're going to do things. And also, one thing that's recurring more and more at the moment is personalization. How can actually, that's the main way that people are upping the production value and making it more attractive, more and more so in an internet-based world. So that's kind of where the customer's coming from. This is my very simple live production workflow slide. So everything from the glass at this end to the glass at the other end in the capture, and obviously the whole chain is vitally important in terms of the end user experience. In terms of the production piece, I guess where we are focusing as a company is very much on the post-camera acquisition through to being part of the production processing itself. But that's the workflow that I'm going to be talking about as we go through that, and very specifically I'm talking about live production workflow rather than NLE work and offline, although the synergy and the convergence of those is interesting. Again, this is a slide you've probably seen before. This is some work we did with the DPP during lockdown, actually, in COVID times, to actually define the different ways people are doing production. So traditionally, this top model was how you did it. Your acquisition devices and your processing and storage and your control were all co-located, either in a studio, in a gallery, or on an OB truck. But now, accelerated by the likes of COVID, but now accelerated with sustainability drives, with maximum use of people, distributed production is here to stay, and many companies are now focusing, big production organizations, on global distributed production, where you have central repositories of equipment that you're using to do the storage and the data processing, your network connecting stuff, and you're sending the minimum possible equipment to site to allow that to happen. And that has implications for, amongst other things, timing. So that's important. And why does it have implications for timing? Because the one non-negotiable in latency is the speed of light and fiber. We can pretty well optimize everything else, although I would deign to suggest that vendors are not necessarily doing that yet, but the non-negotiables there. Actually, if you've seen the gradual rollout of hollow fiber, that does actually take us from 2 times 10 to the 8 up to the true speed of light in a vacuum of 3 times 10 to the 8 meters a second. So there is a 50% advantage which we're not yet leveraging globally because we're still using solid fiber. But that's the only benefit we're going to do unless someone works a real miracle, in which case patent it. Okay, so that's the non-negotiable thing. One of the other big things I want to talk about, and you may have seen this slide I've used before, because this I think is a vitally important bit which demonstrates the real transition we're in as an industry. We are moving from a linear workflow of producing live video, which has been the same for the last 90 years, albeit using different technology over those 90 years, to actually the point where more and more of the actual live production capability is able to be realized in software. And we are, as an industry, on an inevitable journey to this becoming more and more of a software chain of processing elements. We'll talk about some of the implications of that in a minute. But that means that as long as, and this is a very big but, if we have the correct timestamping of all of the media elements that we're pulling in, the video frames, the audio samples, then we don't have to have this curated linear flow of data, which is great if you've got like an analog cable. It's great if you've got a CRT tube that you're scanning. But if you're actually using compute works in burstiness. It just does some math, it shoves stuff across. And we need to make the way we actually do content production much, much more compute savvy. But that has challenges potentially in terms of timing. And much as I absolutely love 2110, because I was a big part of helping to make it happen, that doesn't really work within compute. It works very well in the linear world on the ground, but not within compute. So we'll come back to that a little bit later on as well. So watch this space. There's quite a lot of initiatives that are happening in this space, and I might just reference them a little bit later on, both in terms of how we get in and when I use the term cloud on this slide, I mean compute, be that publicly or privately hosted, locally or remote from where you are. We've got quite a lot of work going on getting in and out of the cloud, in and out of compute, but also, most importantly, getting between compute, because this quite often, although it doesn't need to be as a linear process, this absolutely shouldn't be a linear process, a synchronous process in terms of the way it's working. There's lots of initiatives. So jumping onto that latency, the timing, what's important, what's critical in terms of the way we look at workflow. So we fundamentally, if you want to break a live production into some clumps, we've got acquisition devices and things that we're viewing on. So we're looking at cameras, microphones, tally lights, headphones and monitors and monitors, viewing monitors. So those are the things that the edge devices, if you like. We've got processing and storage, which may well be located somewhere completely different. We've got the control surfaces, be they soft or physical. And then we've actually got the monitoring things at the far end. All of those need to be interconnected, and some of those latencies and delays are really critical, and others actually don't matter that much. And what we're going to do is just dive into those very briefly to have a look at this. So what I've tried to do here, thinking about a production, is which things are really critical in terms of timing, which things are not so critical, and which things actually we don't have to be too fussed about as well. Because I think we're over-engineering timing in some circumstances in the way we do stuff. So most critical, I'll start on this side, is phase coherent audio. I don't think there's a more critical part of any production chain than phase coherent audio, because you've got roughly a tolerance of 20 microseconds and you're stuffed. Yeah, so if you've actually got multiple microphones creating a sound field, then you've got to be sample accurate in the way you're actually putting those back. So that top right is our most critical constraint in terms of timing. Also fairly critical, and it's also in the audio domain, is actually local looping back of audio, especially to someone in their ears, etc. That's probably got like a 5 millisecond target, but needs to be better than 5 milliseconds to make that work. So if you're thinking about like this remote production stuff we've been talking about, things like that actually cannot go in and out of cloud infrastructure. Or cannot really even go long distances. That needs to stay local. If we move down to the next level, then we've actually got some alignment stuff. So for instance, cameras. So if you've got a multi-camera shoot, then they need to be frame accurate. Ideally, you want them to be scanning. But if you've got cameras in a high-speed environment like a sports event you're cutting between, then you need that frame accuracy. So we're talking 20 milliseconds circa here as a target there. We've also got the tactility, if you like, is that a word, of human beings pressing buttons and expecting to see something happen as a result of it. Now, actually, the counsel I have from people actually are involved in doing production is you can tolerate a bit of latency there as long as it's consistent. What you can't do is have inconsistency. I'm already learning to work with 4 seconds latency on pressing this button to my changes. And it took a while. It took me 3 or 4 slides to get used to it. So people can cope with that, but only if it's constant. But even so, it's a fairly tight timing requirement. And that probably needs to be within 100 milliseconds or so for it to feel right. We then have got 2 different sets of cameras, and I wanted to show you this because, again, speaking to people involved in production, I think this is very important. There are some cameras that you want to get back into your production system where that latency is actually pretty important, because if you think you've got some closed loops here, like because the cameraman sees a tally light, and then you've got the people doing the RCP stuff on the shutter control, etc. And there's a loop there between the people seeing that back at base coming back. So you've got like a timing loop there. And also, if the people are actually doing the remote direction, then you've got to have a fairly tight loop there. But if you think about maybe like a 15, 16 camera production of a sports event, typically probably only 6 cameras are being cut between for the main action. A lot of the others are just being used for replay. So, they're just being used to do the slow-mo behind the goal mouth, behind the goal nets, which you never see cut to live. They're just to show the alternative angles. So actually, we've actually got arguably 2 different speed requirements here. This is where I'm challenging some of our, so we have some which are quite critical, but others actually where, maybe this, and I'll come on to some figures in a minute, because I think I did actually put some figures on here, did I? Somewhere around there, yeah. So we've got possibly, and these are not absolute figures, but these are just my starter for 10s. Audio, phase coherent audio, 20 microseconds is your limit. 5 milliseconds for local loop audio, for audio talkback, etc. 20 milliseconds for camera alignment. That's frame-based accuracy there. Maybe 200 milliseconds for the high-speed REMI cameras that need to be in a loop when you're doing remote production. But maybe some of those other camera angles that are just going into ingest into the replay system and are never likely to hit live, probably you can tolerate up to a second on those without actually having a challenge. And that actually, the reason that's critical is you can actually use different types of connectivity compression maybe on there to actually save cost in an environment. So that's kind of just some mindsets of the way we're thinking on the timing periods and where that's going. So timing references, those of you that are old enough, we've been used to various timing references over the years. We used to dial up to find out what the time was. Did anyone else used to reset their original digital watch on the last pip? When you dialed, either the pips received over the radio. And I was absolutely adamant that I would never go to streamed audio on radio, because it means the BBC Radio 4 pips in the UK, you listen to them maybe 15 seconds late. But actually, I don't really care anymore. It just happens, and I accept it. And we don't do any off-air received audio at all in our house now. It's all streamed. So we get used to those timing offsets as long as they're not critical to our lives. Keeping everything in sync is, however, a challenge, and that's something that we've just started to use different technology for. So we used to gen lock our cameras and all the other pieces of equipment in the system, which was basically giving them a common reference, so everything is frequency and phase aligned by doing that. We now use some kind of GNSS reference typically, although people are still talking about the relative security of that, etc. But most things are GNSS referenced. I'm going to challenge in a minute the level of timing accuracy we need within the workflow, but the timing of the acquisition is still very important, because if we've got, going back to my microphone example, if we actually have a number of, say, 5G connected microphones that are forming a phase coherent sound field, then those microphones need to know what actual time is to 10 microseconds accuracy, or else you're not going to be able to synthesize a stable sound field from there. Slightly more tolerance with the video, but those are the requirements that we have when we're running through these things. So typically we take timing and reference and distribute it, and actually we're just doing a similar thing there. reconciling time. So what we have done, the adventure of 2110, the thing that we were trying to do, and we've had pretty good success with that, is actually saying we don't want to take an SDI feed where we've got 1.5, 3, or even 12 gigabits per second of data and feed that into the audio console just so it can extract a few 2 meg audio channels. It's much better if we actually create content, we actually have a timestamp on all of that content. The audio goes on a relatively low to devices that only need to handle maybe up to 100 megs or a few hundred megs of data, whereas the video can go into stuff that can cope with 100 gigs worth of data, be processed, and we will reconcile it downstream. Now, one of the things, and some of you have heard me preach about this a lot in the last 3 or 4 years, one of the things we really messed up on with 2110 was actually defining the way we actually reconcile those essences. Because what happens is, by intention in AES67 and therefore by ripple through on the way we did 2110-30 and 2110-20 and then 40, a lot of things restamp time, and we actually lose that all-important nugget of information, which is the origination timestamp. Credit to the BBC, in the draft work that they did before we developed TR03 and then 2110, they actually had a separate field for the origination time. And more use cases are coming up now where people are saying we need to carry some metadata that allows us at least to reconstruct origination time. So at any point in the workflow, we can actually reconcile and align things. This doesn't just apply to the live workflow, but if you're doing a multi-ISO record to do a playback later, even if you're doing multi-camera angles of a sports event, you want to be able to play them back in synchronism as well. So it's not just the live workflow timing, but it's actually then that timing information being recorded, so when you replay, you can actually do that alignment as well. Anyway, I've done lots of talking on that previously, so I will leave you to do that, but there is still some work in progress happening with that. Now, this is the point the latency's caught me out, because I'm sure I pressed this button about 7 seconds ago now, and we still haven't transitioned. Let me try again. Just going to see if this works. Okay, end-to-end metadata. So this is actually important not just for timing information, but more and more people are seeing the requirement for metadata where we actually need to be able to send information, and it might be information about the native spatial and temporal resolution of the original capture, because if we go through transformations of video and audio as we go through a workflow, it's sometimes really good to know, was that originally 10-bit, 12-bit or 8-bit video that we actually had? What's happened to it en route? So things like that are also very important. Have I run out of time, Lee? No,
we're back a little bit early. So
okay, this is good. I'm just panicking that we might be out there.
I appreciate that, though.
Cool. So we have some things that are actually making things a little bit harder, because, as I've alluded to, we've potentially got things like 5G acquisition running in parallel with traditional fibre or cable-connected infrastructure. So there's some timing uncertainty which we need to buffer for there. We've got more and more compute happening in the middle, which has a much more non-deterministic time to actually produce the results than we used to. So we have to budget for what we are calling, in some of the work we're doing in VSF, T99, but basically T-max. What's the worst case that the compute is taking to actually achieve that? And then we need to do the maths to sum that to where we get to. I think I'm going to whistle through this. You're aware of the SDA 2110 suite, just to say we're still doing some work for a new part called 2110-11, which is all about how we actually propagate some of that timing information. And we did do some revisions to -10 the year before last, which actually goes some way to actually doing timestamp preservation. There's more on that in some of my other talks, and send me an email if you want to go through that. Just looking at timing planes, because this is what we're calling the work we're doing in SMPTE very briefly, just this one slide on this. There are some timing planes we intentionally introduce in live production. We may intentionally say we want a profanity delay. We're intentionally to delay the whole program before emission for 5 seconds or 10 seconds for profanity. If we've got remote control surfaces, we know we may have a non-negotiable 300 millisecond round loop to do that. We may have an augmented reality set which costs us maybe half a second in the VR synthesis that goes alongside. So we've got a whole load of cameras that are straight straight time, but we've got other cameras that have effectively got a half a second lag before we can put them into the system. So all of these things have to be taken into account before we do the final tape layout. And it's just obvious that all of these offsets should be able to be handled automatically. It's just numbers we're handling with, and we really haven't got there as an industry yet to actually doing so. That's really important. I think I've already covered this, talking about the fact there's a variability in compute processing compared with traditional appliance processing on the way things are handled, and we have to do that Tmax there. And this Tmax, and just to pull this out, courtesy of the GCCG work we're doing here, that Tmax obviously accumulates. So those uncertainty factors, you have to allow the accumulated aggregate maximum of those things as we actually go through the system. Okay, another little thing I want to lob in here. I know various both public and private software cloud providers are advocating and are flagging that they can soon will be able to do PTP in cloud. I would argue very strongly you don't need that accuracy of timing within cloud infrastructure. If you think about all of those bits that I talked about, the critical thing is the acquisition. As long as we timestamp on the acquisition devices, both the audio and video time devices, once we're within the compute, most of what we're doing is maths on saying this frame with this frame with this frame, or this audio sample is actually the coherent sample with that one and that one. We can align them numerically, do the math, whatever that is, to do the crossfade, to do the effects, whatever you want to do. NTP, in my opinion, is more than sufficient within compute infrastructure to do what we need. When we come back to linear 2110 worlds, we then need to actually have some buffering that can synthesize as a boundary point back into PTP world. But compute doesn't need to do very, very high precision timing. It's just doing maths on accurate numbers it already has. And I think that's a really, really important part. Just talking about other timing things, you may have seen that there's been a couple of different standards that are being used here for JPEG XS. Just as an example, JPEG XS is a mezzanine compression, roughly maybe something like a 6:1 or 8:1 compression that's being used for very high quality, very low latency compression for production. The actual compression decompression cycle is less than 1 millisecond. So if you're long hauling, the compression element is negligible because it's just so far. We're actually using two different ways of carrying that within the infrastructure. TR08 is the way we do it if we're in a PTP-enabled environment where we've got, if you like, ground-to-ground timing references, where we've got GNSS referenced phase and frequency accurate timing. TR07 is more like it is transport stream based. It's like MPEG transport streams we've been handling for the last 25 years. And basically, that's what I call forward clocking. You can recover the information from the system. So you don't need to worry about phase coherent locking and frequency coherent clock recovery at the far end. You can recover it from the stream rather than needing to have the same timing reference at the other end. So these tools allow us to service different elements, and possibly the reason we're seeing a lot of use of TR07 in cloud infrastructure is because that means you haven't got to worry about PTP referencing in the cloud as you go in. I'm going to jump through that because that's just a bit more explanation on timing. I am going to throw in another grenade here. As we've gone through 2110 and also in compute, the way people are solving a lot of timing issues or potential timing issues is by adding lots of frame buffers in. So a lot of people are designing things by actually saying, as I receive a thing, I'm going to do a full frame sync. As I push it out, I'm going to do a full frame sync. If you concatenate that over maybe 7 processes in a production lifecycle, we've suddenly added 14 frames of delay just to allow us to synchronize. Most of them are completely unnecessary in the process, but people are doing it, dare I say, I think out of laziness or just safety that's unnecessary. And that's applying both in 2110 ecosystems and in compute software design. And I would urge people in the industry to actually get their act together and only introduce necessary latency. So fundamental challenges: we have linear connections like 2110, like SDI. We have this non-linear compute-based way to workflow. We need to sort out capture time. We need to be able to track time as it's used through the system, and we need to be able to optimize that by decent design of the way we do things. Okay, that's been a real whistle-stop talk. Hopefully it's given you some nuggets. The idea was only to get you interested in things. I'm always at the end available on my email or on the phone if you'd like to actually talk to me at any point. And my offer, which Mr. Wes Simpson took up last week, if you're ever in the UK, come over to my house and I will make you a very nice cup of tea. So that's it for me. Do we have any questions or observations?
So it works? Yeah. So as I understood, so TR07 will be very helpful to transfer the streams to the cloud, and TR08 works when there is PTP. But inside the cloud, when different systems have to communicate between each other, so what's there the best technology choice?
Excellent question. So both TR07 and TR08 are what I call streaming interfaces, like NDI is, like SDI is, like 2110 is. And in fact, TR08 is part of 2110. It's 2110-22 is what TR08 is. In compute, we shouldn't be using linear streaming interfaces. We should be using native compute-friendly data handoffs. The only thing that's been published in the world, and there was a reference back to it, I didn't call it out on one of the slides, is the work the GCCG has done. It's on GitHub, so if you look at the GCCG work on GitHub, I wonder if I can just backslide to that to show you that. It was fairly early on. It's going to be very slow with this because of my 4-second latency each time. But there's some... basically a draft has been published already, and this is a native asynchronous compute interface. Now, one or two vendors are doing something like that internally within their closed ecosystems, but the GCCG work is the first work where we've published as an industry something that might do this for us. We're not claiming it addresses everything yet. It's a draft and it needs more work. We as a peer have just implemented a prototype of it and it looks pretty good. But yes, we don't want linear streaming interfaces within compute. We want to be able to do native asynchronous handoffs. So, so this is a clump of data. It's the next 4 video frames, or it's the next 47 audio samples. Probably not 47. Let's make that 48. And we're going to dump that across. And that's what we really need to have within compute. So check it out on GitHub. And if you look at the VSF, you can see we've actually published that. But message me if you can't find it. I'm just whistling back now to see if I can actually find the slide with that on. I think I put it quite near the beginning, which is unfortunate with the latency I'm experiencing here. So I'll keep whistling back. I'll put it up at the end so you can find it. Any more questions or observations? There's a very silent man at the end there that I expected to throw some kind of grenade in, but he's just sitting there respectively. Go on, one last from Ed.
Give us a preview of Dash 11 then. How are you going to solve the problem of the origin timestamp? What's the recommendation going to be?
So what we say in Dash 11, which is the work that GCCG is doing, is basically you have to maintain that acquisition time, and you carry that as information. The thing is, the reason people, even within 2110, have existed and managed to exist without propagating origination time is because if you've got like a hosepipe effect where everything, you push through like 30 centimeters of water and then the next 30 centimeters of water comes through and the next 30 centimeters, then everything you can do relative. But if you're just lobbing stuff into compute and it's doing maths, you have to have timestamps. Otherwise, you haven't a clue what the hell's happening. So we prescribe that you absolutely have to have timing. Now, there's 2 ways of doing that. Ideally, what we say in TR11 is you take the origination timestamp as came from the ground. So the original acquisition timestamp from the camera. Failing that, what you do is as it hits the cloud, you create timestamps on acquisition into the cloud, So as it comes in, and then you give the ability for offsets to be applied to allow for the differential latency, which will hopefully be static between the different ingress points. But ideally, and there's still more work to do on this to make sure that things like TR11, TR07 transfer timestamps in an accessible way through there. But thank you for the question, very pertinent.
Does that mean preserving RTP timestamps or introducing header extensions?
Well, because we're talking about data file worlds, we're actually taking effectively what was the RTP timestamp and converting that into a usable timing reference. Whether we should go for header extensions in a linear world, I think that ship has sailed, and I say that with a very heavy heart. And the reason it wasn't done is people thought it'd be too hard for FPGA implementations, which is very sad. So, oh, we must have gone past it now. That's interesting. I will find this reference in a minute. But so I think the header extensions, but we are looking at saying there's an additional standard which hasn't really been used yet, -41 in 2110, which is a fast metadata channel, which allows you to send maybe even allows you to send frame accurate information. So one of the suggestions is we occasionally send metadata which has the relevant offsets between the current timing reference you've got and the origination time. So you can actually carry enough information for you to derive in origination time. It's a little bit messy, but within the compute world, when we do the data handoff, yeah, we are absolutely saying you have to preserve origination time, even if it's only origination with respect to the ingest point to the compute. Hopefully, it's actually the acquisition point of the microphone or camera. Okay, is that good? I could talk forever, so I'll shut up now. Thank you for your time. It's been a pleasure talking to you. Thank you. Here we go. There's the GitHub reference if you want to grab it.